So you can start, sir.
So with the blessings of our Honorable Founder President, sir, in the second day of International Conference on Materials Medicine and Information Technology 2022, ICMMIT 2022, we are successfully completing the first day, and now in the second day, we are heartily welcome to Dr. Sudhanshu Ranjan Das in the first session of Virtual Room 2. Today with us, Dr. Sudhanshu Ranjan Das sir as a keynote speaker, and sir will also chairing the session after speech, and also conference convener and co-chair Dr. Praveen Kumar Singh sir also with us is this second virtual room of first technical session. So before moving to the speech of Dr. Sudhanshu Ranjan Das sir, let's firstly introduce about Dr. Sudhanshu Ranjan Das sir. So first of all, on behalf of the organizing team of ICMMIT 2022, IMIT University, Jharkhand, I heartily welcome Dr. Sudhanshu Ranjan Das sir. Dr. Sudhanshu Ranjan Das sir is currently working as an associate professor in the Department of Production Engineering, the Surendra Sai University of Technology, Burla, Odisha. Dr. Das sir received Bachelor of Technology in Mechanical Engineering from Biju Patnaik University of Technology and later Master of Technology in Manufacturing Engineering from Kalinga Institute of Industrial Technology, University, Odisha. Sir received PhD in Manufacturing Engineering from National Institute of Technology, Jamshedpur. Dr. Das is the profession of teaching and research since last 14 years. His current research interests include hard machining, machining process modeling, optimization, sustainability manufacturing, green machining, development of coated cutting, tool materials, and many more. Their research publications include 25 SPI and 41 Scopus Index journals. They are already written 3 books and 8 book chapters and 5 patents in his pocket. He has presented 27 papers in various international and national conferences. Sir also has delivered many talks in various international and national conferences, seminars, FDP, STTP, and workshops. He has guided 7 MTech students and presently guiding 2 MTech and 4 PhD scholars. He has received awards from Institution of Engineers, India for Pratap Chandra Panda Memorial Award in the year 2019, from I2OR for Distinguished Researcher Award, and from Green Thinkers Jet from Outstanding Educator Award in the year 2019. There is the member of many professional societies. So we are very much fortunate that today with us Dr. Sudhanshu Ranjan Das sir. So I heartily welcome once again to Sudhanshu Ranjan Das sir, and over to Sudhanshu Ranjan Das sir for his expert talk on machinability study of authentic steel under various cooling lubrication strategies. Over to Dr. Sudhanshu Ranjan Das sir.
Many thanks, Dr. Amit Kumar Datta, for nice introduction. I just thanks all. Good morning to all the participants of this conference, and I especially thanks to Dr. Praveen Kumar Singh, convener of this conference, and inviting me in this occasion. And so we'll start with my presentation of that. I think my slide is visible.
Yes, sir.
Okay. So, so my today's presentation that already Dr. Amit Kumar that I have entitled the subject of speech. So again, I am repeating that my today's discussion of that speech is that machinability study of austenitic stainless steel under various cooling lubrication strategy. So basically, these steels are extensively used in the various applications nowadays, and basically because of huge demand, So and due to the lots of challenges of during the machining, so the machinability is a very prime concern. So in this case, the austenitic stainless steel has different demands in a different application and different industries like architectural building and construction, oil and gas power industry, food processing equipments, medical applications, nuclear power system, automotive components, and machine tools. So these materials are, because of due to the importance for different application, because of due to the improved properties or critical superior characteristics like corrosion resistance, abrasiveness and indentation resistance, high specific strength, heat resistance, load utility, and improved impact as well as the shock resistance. So apart from this, so due to these specific characteristics or specific attributes, this material for during the machining is challenging. So machinability of these materials are prime importance whenever you consider the different challenges. So these are the listed that I have shown in the slide. So if I go to the one by one, the most one important is that during the machining, as the cutting tool deformation due to hot hardness and strength of workpiece, occurrence of machine tool chatter and excessive tool wear. And another important thing is that rapid hardening of these alloys often lead to notch wear and the nose tool wear. So basically, if I'm concerned about the machinability of austenitic stainless steel, so most important thing is tool wear is more, because the tool is very facing a very harassing environment of temperature as well as the friction. So it is most important that efficiently to control the what the tool wear during the machining. And second most important thing is that during the machining of austenitic stainless steel, so there is a different temperature or the heat generation during the machining is very high. And so that's why the control of the temperature during the machining at the different interfaces of the workpiece and the tool as well as the chip at the tool is also one of a major concern of that. So in order to that, there is a so that's why the machinability is, as it is a most important for any cutting operation. So machinability, there is a different way you can define. So particularly the machinability is it is a quantitative way in which you can measure by a different parameters. So here these are the parameters just I have few have listed. If I'm going to that, the major parameters are the material removal rate, cutting forces, surface roughness, tool wear, power consumption, cutting temperature, cost of machining, and chin morphology. So other parameters are there. So mostly the researchers are used for their machinability investigation during different kinds of material by considering these parameters. So if I'm considering for a machining, the good machinability is always desirable. So if I go for a good machinability, we can say that the good machinability can be possible when the cutting temperature is low, power consumption will be low, tool wear will be low, surface roughness will be low, cutting forces will be low. However, the material removal will be high because of it is mostly depends upon the productivity. So these are the things to be considered for a good machinability if you predict or if you go to the high machining performance during the machining. Apart from this thing, there is a lots of parameters in which the machinability is dependent. So that is, you can say that it is the process variables where the machinability of a hardened steel is purely dependent. So if I'm going to that, in the machinability of a hardened steel is dependent upon the different variables. So these are the list. If I'm going to that, operation, cutting data, insert geometry, insert material, coolant, chucking, workpiece material, and machine tool. So I need not to go to the all the details because the time is limited. So if I will go one by one to a small of a silent point, so that it will be better for the participant to easy understanding. So apart from this process variable, there is a what a complexity nature of what machining of austenitic steel. So that's why it is important to what the control of all the process variables. It is important. So there is a what to control these parameters in a to get a good machinability. There is a lots of modeling and optimization technique has been developed, which is used to what to develop to model as well as to predict or to control the what different process parameters or process variables during the machining of any kind of the material. So if I'm, let's say, example of the optimization technique, the most statistical technique has been developed by the many researchers that have used for the to control or optimizing the different process variables like Taguchi method, GRA, principal component analysis, desirability function approach, genetic algorithm, which are the genetic and particle sum optimization, which are the computational approaches there. Similarly, there is to predict or to control the different parameters in a machining. So there is a different modeling has been developed by whether it is a statistical modeling or maybe it is a analytical modeling. So this is not my discussion of that talk. The main important is that the issue in the challenging of the machinability challenging during the machining of austenitic steel. So I just have just 1 minute to go just overview that the most prime concern of the machinability challenges during the machining of austenitic steel is the tool wear and the cutting temperature. So if you'll go to the tool wear, there is a two kinds of tool wear is basically occur during the machining of austenitic steel. One is the frank wear, and not a austenitic steel. For every kind of the material, the most important tool wear is the frank wear, then is the crater wear. So basically the frank wear is occur due to the severe rubbing effect of the machine surfaces to the flank edge surface of the tool. So that creates a progressive development of the wear as the tool proceeds. So that is named as a flank wear. And second one is called the crater wear, which is generally occurs at the rake surface of the tool, or you can call as a top surface of the tool. So that is called the rake. So this wear is called as a crater wear because of due to the heavy sliding of or severe sliding of the hard chips during the machining. So it creates a disappearance of the material or the stickiness of the tool material with the chip. So it creates a void or a disappearance of the material in the tool surfaces, rake surfaces. That is called the crater wear. So if I'm going to the tool wear in this case of a machining, so the measure the tool life or the tool performance is basically depends upon the frank wear. So that's why the researchers are basically, or the the investigator are basically used to how to minimize the frank wear in the during the machining of a different kinds of steel. Here we are discuss as is austenitic steel. So the minimization of the frank wear is prime important. Apart from this, so this important can be only be possible by using the what they that we have discussed the different process variables there. But however, the most important thing is that the selection of the tool material is prime important. Because of why? Because these austenitic stainless steel is comes under the what different hard and difficult to cut material category. So that's a for difficult to hard and hard to cut category materials are rarely machined by the what ordinary tools. So ordinary tools here I am say high speed steel or plain carbon steel likewise. So nowadays the most three usable tool that has been developed for machining of hardened as well as the difficult to cut material. These tools are carbide tool, ceramic, and the CBN tool. So CBN stands for the cubic boron nitride, which is a equivalent hardness of the diamond. So you know that hardest material in the world is the diamond, and hardest metal in the world is the tungsten. So we can say that. So these are the tool material which is comes under this category. That does not mean that it is a pure titanium or pure tungsten or pure diamond. It is just a constituent elements of like this element, these elements. So if I am going to that, this selection of the cutting tool, these have a specific reason to select this type of cutting tool material. So what is that? So these materials are high hot hardness, high coefficient, low coefficient of friction, high thermal conductivity, high toughness, and high wear resistance. So if I'm going to that one by one, so high hardness is called the ability to retain the hardness at a elevated temperature, elevated cutting temperature. Thermal toughness means what? Ability to load or to absorb the shock load during the machining, because during the cutting the tool tip is subjective what intermediate cutting because of what due to hard constituent particle present inside the workpiece material. So when the tool tip is interact to these hard constituent particles, there is a shock load will be what act onto the cutting tool. So there is a chances of the breakage. So in order to avoid these things, the tool should have a high toughness as well as the wear resistance. So nowadays there is a different types of cutting tools has been developed, and coating material is also developed, which is used to what increase the tool life or increase the tool performance more better than the substrate material. Now will we go to that of a heat generation. So previously we have discussed there is a two major concern. One is the wear, tool wear, another is the temperature. So in this case, during the machining, as because of due to the specific characteristics of a austenitic stainless steel, so that we have discussed. So this material due to these characteristics, so austenitic steel becomes difficult to cut category material. So that's why So because of due to this category, so during the machining, that the major challenges is the tool layer, and second one is the secondary is the cutting temperature, that is the heat generation. So as of us in the theory of metal cutting, or you can say that in the machining science, it says that during the machining, most of the heat is carried by the chip and rest are transferred to the workpiece, or either it will be not either, it is exactly transfer. Some temperature is transferred to the workpiece and some heat will be transferred to the temperature. So here, if the heat is not carried properly by the chip, so there is a severe effect to the tool wear. So that's why it is important, if when the chip is not carrying the temperature very efficiently, so it is a prime concern to control the temperature at the cutting zone immediately. So nowadays, so in order to avoid this thing, so there is a efficient cutting fluid has been developed. That cutting fluid is not only to raise the temperature, it also removing the heat from the cutting zone, removing the chip by the flushing, and reduction of the tool layer by due to the making a tribological layer in between the workpiece and tool surfaces, and better surface finish because of due to the it is avoids the tool and the workpiece by a thin film layer of lubricant. So in this case of that, so there is a different techniques has been developed, which is used to use the cutting fluids by supplying into the cutting zone in a different techniques. So the techniques are called either it will be the techniques has been developed by the two different category. One is either it will be dry or it will be a wet. So abscess of the cutting fluid machining is called the dry machining. Use of the cutting fluid during the machining is called the wet. So whenever you go to the wet machining is categorized in a different techniques that has been developed to supply the cutting fluid in a different way. So if I'm going to that, the techniques are in the wet machining is categorized again: flooded, nanofluid, high pressure cooling, cryogenic cooling, and the minimum quantity lubrication or near dry lubrication. So will we go to that top one by one to that? It will be, I think the video is visible. I think video is visible.
Yes, sir, it is visible.
Okay. So these are the some of the interesting videos is that in which we can categorize that how the cutting fluid is applied in a different techniques. So this one is the compressed air cooling. So compressed air cooling is what it is. It is a one kind of the dry machining, but it used as a compressed air as a medium of a cooling agent, which forced into the cutting zone through by a high pressure nozzle. So this is the one kind of the compressed air. So this is the one kind of cooling which is use a huge volume of the cutting fluid. That is called the flooded. So this is another kind of cooling which is used high pressure cooling, that is supplying the cutting fluid with a high pressure into the cutting zone. So due to the impeachment of the high pressure cooling, it will be suddenly reduce the temperature. And another which is emerging new technology that has been developed in the era of cooling lubrication technique, that is called the minimum quantity lubrication. It is just like a technique of what it is consuming the cutting fluid. It is almostly no, that is you cannot say zero. It is almostly it is very negligible way. So it is just like a spraying the cutting fluid in a nano mist form and directed at the pin at the cutting zone. So due to the heat transfer capability of this cutting fluid, it is even effectively and efficiently remove the temperature at the cutting zone, and also it also makes a layer of tribological layer in between the workpiece and the tool, as well as the chip and the tool. So that's here we can say that the empirical technique is not only consuming the cutting fluid, is also it is a healthy environment. That means you can say that it is a one type of a sustainable environment for machining. So another kind of the machining which is called the which is not exactly practically used because of due to the highly environmental concern. So if I'm going to that, they have a highly negative environmental impact, that is called the cryogenic cooling. So in the cryogenic cooling, you can use as some liquid nitrogen and CO2 that is used as a coolant, which makes a chill environment or shielded the chill environment of the workpiece and tool prior to machining. So this is already the workpiece is shielded with a cryogenic cooling. So that is already shielded, means it is below the room temperature. And in the meantime, during the cutting, there is a passage of nozzle which is supplying the liquid nitrogen that has been developed to control the temperature or minimize the temperature, as well as to make a lubricative oil in the between the interfaces surfaces. So if I am discussing in these cases of liquid nitrogen, because it is not in the cryogenic is not popular because of due to negative environmental effect and is the carcinogenic of because of due to the liquid medium. So that's a, but if I'm consider this thing, so nowadays the cooling lubrication techniques has been developed due to the the improvement of the cutting performance, as well as to to make more effective and efficient of the cooling lubrication efficiency during the machining. So another kind of the machining that has been developed also newly, that has been what I have worked a lot in this area also, that is it is a nano fluid, or you can call it a nano cutting fluid. So in this case, what is that? Whenever a cutting fluid is mixed with some nanoparticles, ultra hard nanoparticles, it is called as a nano fluid. So when the nano fluid will be interact with the workpiece and tool zone, so the particles has been present into the in between the surface of the tool and the workpiece. Instead of the tool will be rubbed with the workpiece surfaces, the tool will be start to roll or cushioning effect onto the workpiece surfaces. Because of why? Because the sum of the nanoparticles act as a ball bearing effect. So in the meantime, there is a base fluid is there. So this base fluid is also helps to also as a lubricating, as well as to to control the temperature. So these are the techniques has been developed in a way of to control the temperature. So in order to validate this thing, as we have discussed, there is a various number of techniques has been developed, cooling lubrication techniques has been developed. So in order to that, I just go through a case study which have already been published of some of the some part is published in a particular journal. So in this case, I consider a four different of cooling lubrication techniques. So that techniques is called the techniques of dry, that is without coolant, techniques of cooling lubrication of the flooded, and techniques of MQL, that is minimum quantity lubrication. And we consider that which technique is performance wise or cutting temperature or performance wise it will be better. So that we consider a ceramic tool, that is it is not a alumina base, it is a silicon base. Mostly the tools which are used for the in the machining of hard to cut material, or either it will be difficult to cut material, the tools are basically alumina based. But in these cases we have selected one kind of new kind, that is not a new, that is rarely reported in the previous studies. So it is silicon based. So we know that why a silicon is used. Silicon is not only improve the properties, is also improve the strength as well as the hardness of the material. So here is the tool material. So whenever you do to this kind of the tool is used, so this kind of tool is used because of what it can operate with a high cutting temperature as well as the material up to 70 HRC. So that is, you can say that the material is very efficient to cut any kind of hard to and difficult to cut material. So to perform the machining, we go to a turning operation in the lathe machine, that is a HMT NH26. And to evaluate the different machinability parameters that I already have told, that the machinability can be judged by a different way, material removal, surface roughness, cutting force, and many more things are there. So here we can machinability can be judged by the different parameters. So here we can consider in this case study we have discussed, we have considered the surface roughness, temperature as a measuring by thermal imaging camera, piezoelectric dynamometer to measure the cutting force, and optical microscope to measure the tool layer, and scanning electron microscope is also used to observe more better illustration of the tool wear. So in this case, these are the some various equipments has been used to measure the various machinability parameters. So after measuring that, after the selecting the output characteristics, we go through to machining. So prior to machining, we select a particular kind of the machining parameter that is called the speed, feed, depth of cut. In this case of the machining, we consider the depth of cut as a constant, whereas the speed and feed is varying with 4 different levels, and these are selected based upon the previous literature review and the tool catalog manufacturer. That is the recommendation of the tool catalog. So in this case, the tool that you have selected is the CLN ceramic tool, which is procured from the Kenametal. So these are the techniques that you have developed. So we have considered the 4 different techniques of cooling lubrication technique. Here this is the first one is the dry, that is no coolant. Second one is called again it is a dry because of it is use a compressed air as a coolant. So it is again it is a dry, no cutting fluid is there, liquid medium is there. And third one we are using a cutting fluid which is a product, that is consumption is high, and the last one we are using a MQL, that is the consumption rate is almost no or zero or negligible. So MQL, minimum quantity lubrication. So we consider the 4 different techniques of cooling lubrication techniques to evaluate the cutting performance of a austenitic stainless steel. So in this case, we have used a particular, this is the schematic layout in which we execute our plan of research in a different way. So this is the overall schematic to represent all the machinability parameters. So we'll be discussed one by one. So we start with the first one. We calculate or we evaluate the machinability of austenitic stainless steel by the character wear analysis. So in this case of the character wear analysis, what we can get? So these are the images of the character wear. So character wear means you know that there is a 2 different wears are there, flank wear and the character wear. So character wear generally occurs due to the heavy sliding of the chips on the rake surface of the tool. So as you can see in the 4 different cooling lubrication techniques, we can see that the dry has a high character wear as compared to the MQL. So this and flooded is minimum as compared to the what dry and compressed air, where the lowest character wear is observed in case of the cooling under MQL condition. So this is the reason. The most reason is that in dry as well as the compressed air cutting condition, due to the weak heat transfer capability of cooling medium, enormous quantity of heat is developed at the interface of workpiece and the tool, which is responsible for the heat is developed and development of the thermal stresses that leads to starting of crack, or you can call as initiation of the cracking. And if I'm considering the same thing in view of MQL condition, as the cutting medium is applied in a jet form with high pressure, it is effectively extracted heat from the cutting zone and resulting decreases in thermal stresses built up cutting tool. Thus a very less chipping, or you can call as a less notch chipping was observed in this case of a MQL condition. So similarly, we go to another kind of the tool wear, that is the flank wear, to judge the machinability. So this figure shows this in this slide is the shows the flank wear of the cutting inserts in a different cooling lubrication technique. So again, we have found the maximum wear on flank surface of the tool in a dry cutting environment, whereas it is minimum in a MQL cutting. Since coolant is not applied in dry turning, the heat generation during cutting is accumulated at the cutting region, causing rapid increase in cutting temperature. This high temperature promoted the formation of knots due to high thermal stresses and adhesion of melted chip to the flank surface of the tool. So due to this improper lubrication, that we can say chipping and abrasion type of wear are also seen on the flank face of the cutting tool. So that makes a more tool wear in this case of a dry. So whenever you considering the in the MQL, due to the effective cooling lubrication capacity, slight edge chipping, negligible adhered material, compact knots, and very smooth abrasion marks were noticed. So this one is another kind of response that we have judged by the machinability, that is called the cutting temperature. So this figures in the slide shows the IR thermography image of cutting temperature in different cooling lubrication methods using thermal imaging camera. So it shows that the lower one is show the signals of image of the cutting temperature under different cooling lubrication technique. So from this slide, we can say that the use of coolant reduces the cutting temperature by providing highly effective and heat extractive medium as well as the lubrication. In addition, the reason for less heat generation in MQL condition is that heat friction, or you can call it the friction at the tool work interface and tool chip interface, decrease as the contact length among the tool chip is reduced. Similarly, we go to the another machinability performances, that is called the cutting force. So in this case, particularly we have not go to the 3 different comparative study among the 3 different cooling lubrication technique: compressed air, flooded, and MQL. So if I'm going to that, so it say that it is cutting force under several circumstances. So circumstances means 3 cutting lubrication techniques, cooling lubrication technique. Because of it vigorously relates the other machining attributes like tool life, machining temperature and machine surfaces, and chip morphology and other surface integrity parameters. So cutting forces is also a prime concern. So from this figure you can say that maximum cutting force was noticed with compressed air cutting condition, and the lowest cutting force is observed in the MQL. So in this case, again we can say that in MQL technique, because of the suitable positioning of the coolant delivery system, moreover the minimal flank wear is observed as reported earlier in the MQL turning compared to other machining environment. So this might be the reason for the what, the lower cutting force in case of a MQL condition. And the last one will be go to the what, the which one is the most important to judge the machinability of a hardened steel, that is called the quality index. So which is the surface quality. So during the machining we can say that the surface finish is the should be minimum, or we can call this, sorry, the surface should be maximum. That means the surface roughness should be minimum, so that there will be high acceptance rate by the quality demand. So in this case, these figures in the slides, the upper one will be show the non-contact type 3D profile images of the machine surfaces under different cooling lubrication technique, whereas the lower one in a different color, it will show the 2D-dimensional optical images of the machine surfaces under different cooling lubrication technique, where in the slides of the lower images are the scanning electron images of for different machine surfaces under different lubrication techniques. So here we can say that in the MQL condition it will be present a lower peaks compared to the other machining conditions. So peaks means what? That is the machine surfaces is associated to the peaks and valleys. So if I'm considering in this case of MQL, the peaks are very minimum in height is in comparison to the other techniques. So when the peaks will be more, the roughness will be more. So we can say that MQL has a lower peaks and small rate of feed marks are there. So you can say that MQL is giving a better surface finish in comparison to other. So in this case, whenever you considering the increase of principal cutting force is also take a major concern, as the MQL is supply a minimum is associated with a minimum cutting force. So hence the broader and deeper feed marks are very less in comparison to dry and compressed. So that's a which is also a responsible factor for minimization of the cutting, minimization of the roughness in this case of the MQL condition. So again, we go to the another parameter to judge the machinability of a hardened steel, that is called the machine surfaces, that is of a white layer formation. So basically the during the machining, in this case of a different lubrication technique, it is to be noted that white layer thickness is increasing when the cutting environment changes from dry to MQL. So white layer formation takes place during the machining depends upon 3 major factors. Either you can say that rapid heating and rapid cooling, or rapid quenching, plastic deformation of the surface. So this is the major region in which we can say that the white layer will be takes place. So when the white layer will be takes place, the surface of the upper layer, that is quite different to the lower layer, that is main layer and the sub layer. So in this case, as discussed earlier, the temperature will be increased at medium zone with speed in dry cutting condition. So because of the effective heat transfer and severe shear deformation in dry and compressed air condition, this is the reason for increment of white layer formation thickness. Additionally, in the present investigation reveals that the development of the flank wear in the dry cutting condition is high. So this one is also one of the another reason to formation of the white layer, increased white layer in the dry cutting condition. So if I'm considering now in this case of a condition in the MQL condition, so as what we can say, as the heat dissipation is properly transferred in the MQL condition, so that's why the resulting high temperature is minimum. That means that the resulting cutting temperature is minimum. Hence, we can say that the least heat affected zone will be formed into the machine surfaces. So we can say that hence we can get the less of your white layer in terms of a qualitative way of thickness in this case. So these are the images of that. The upper one is the white layer in the optical microscopy image, whereas the lower one is called the scanning electron microscopy image. So it is clearly revealed that the white layer is more in the dry because of the high temperature and high surface deformation. But whenever you consider the MPL, as due to the effective cooling lubrication technique, so the temperature is becomes low, as well as the plastic deformation or the surface deformation is less. Next, the last one we have discussed, or we can judge the machinability of a hardened steel, machinability of a auxiliary steel in a different cooling lubrication technique by using its tool life, by considering the frank wear up to 0.3 mm. So according to the standards of ISO 3685, it says that the tool life can be ends when the frank wear is reached up to 0.3 mm. So that means exceed of 0.3 mm, we cannot use the same tool for the further cutting. So by considering the frank wear criterion, we consider the tool life of a cutting tool. So what we can see, so to get the 0.3 mm frank wear in a different cooling lubrication techniques, we found that the MQL result a high tool life of about 81 to 80, sorry, it is in exactly 81 minutes of tool life to reach 0.3 mm, whereas in this case of a dry and flooded, and we can say that in the dry, flooded and compressed air condition, the tool life is what comparatively less in MQL. So this is the reason. The main reason is that due to the effective, efficient cooling and extraction capability of the heat from the cutting zone, so the tool life is not such harassing environment in MQL as compared to the other cooling techniques. So that's why it results a better tool life in comparison to other three cooling lubrication technique. So in order to that, we again go to that the last important parameter by the machinability, by cost of machining. Again, we see during the machining of hardened steel, during the machining of the auxiliary steel, the cost under the machining cost under different cooling lubrication technique, it is varying, and we can see MQL results a lower machining cost of 19.79 rupees, or almost it is a 19.80 paisa. For machining of a one product in comparison to the dry and compressed and flooded, they are giving a huge of machining cost to in comparison to the MQL condition. So that is, you can say the 26.81, 23.4 and 21.76 rupees of dry, compressed air and flooded respectively. So that here you can conclude that in this slide that the MQL is giving is more economical cooling lubrication technique as compared to the other three. So from my conclusion, we can say among four lubrication conditions, so machining of MQL technique have shown an excellent performance in terms of improved machine surface morphology as well as the surface finish, reduced cutting force, minimum cutting temperature and minimum tool layer. Machining under different cooling lubrication techniques under dry, compressed air and flooded MQL experienced the tool life 34, 47, 73 and 81 minutes respectively. That means MQL giving a longer tool life. So this outcomes signifies a increase of the tool wear respectively of 138, 72, 11% dry, compressed and flooded condition. And whenever you considering the comparative economic analysis, the machining under MQL resulted a lower machining cost of 19.79 rupees, 19.79 paisa as compared to the other cooling lubrication techniques. So that means we can say that as the cutting fluid consumption rate is less and it is effectively transfer the temperature from the cutting zone and also control the tool layer. So MQL is efficient to what a sustainable and green machining process to effectively to the control or cooling lubrication techniques in this case of a machining. So with this, I just conclude of that in the time bound I have tried to complete this my talk. So if you have any query, you can ask me. It is.
Thank you so much. Thank you so much, sir. Sudhanshu sir, for your.
I am because of more fast to express, because why the time is limited, so I try to complete my presentation with that time bound. So because of some.
Yeah, definitely, sir. It is very precise and informative.
Okay. Thank you. Thank you.
And on the same time, few questions we are just having in the chat box. Sir, just I am taking because now it is 10:11. So
Yes.
what are the solutions to avoid build up edge during machine of
Yeah.
steel?
So
Um,
generally there is a different regions are there in the built wedge formation. So if I go to the example of a built wedge, the major reason is that stickiness of the chip on the crater surfaces, or the sorry, not crater, rake surfaces. So generally it will be takes place when the chips are hot and hand, and it is not effectively there is a, if there is a tool chip contact length will be more. In these cases there is a the built up edge formation chances will be high, and generally this will be takes place when the cutting speed is low cutting speed. Basically in the during the machining of the high cutting speed, the built up edge formation can be avoided. Or if you use a effective cooling lubrication techniques by a high flushing pressure, then the built up edge can be avoided due to the due to the avoidance of the rubbing effect between the tool and chip interfaces. So this is the main reason. So we can say that and also it is also built up edge formation will takes place due to the high plastic deformation, when the plastic deformation will takes place more because of due to the high temperature in the cutting zone. So as you know, the MQL is giving resulting in lower cutting temperature, so there is a less chances of the built up edge formation.
Thank you, sir. Another one question: what type of tools will be perfect for Inconel based workpieces?
For Inconel based workpieces, if we go for a low cost cutting tool, it will be better for a coated carbide. I am not saying about the carbide. It is, we can go to the coated carbide, it will be better. So because of nowadays most of the researchers are looking for a low cost machining process, so coated carbide will be better. But whether it will be a single layer and multi-layer coated, so if it will be a multi-layer coated thick coating by CVD, by coated by a CVD technique, it will be better for a better results for Inconel based material.
Thank you so much, sir, for your wonderful speech. And you will also be as a session sharing during the plenary lecture.
Sure,
Which will
sir.
start in right now. Now, the first.
Now can I say, stop my share
Yes,
slide?
sir, you can stop sharing. Already we stopped
Oh,
your
yes.
sharing.
Sorry.
First, first plenary speech will give technical first presentation by Mr. Suryang Divedi. So I request Mr. Suryang Divedi to start your presentation. You will get 6 minutes time, 2 minutes followed by the question and answer session. So total 8 minutes will be permitted.
Okay, sir.
Okay, so Mr. Suryang, kindly please start your presentation.
Okay, thank you so much, sir. Sir, this is visible to all?
Yes, it is visible.
Yes.
Suryang, kindly please make it in slideshow mode and start your presentation. Suryang.
Good morning, sir. My name is Suryang Divedi. I'm a research scholar at ICMMIT Denmark. I'm here to present a topic of wetting behavior of selective laser melted biomedical based 316 alloys. These are the list of content which we gone through during PPT, and now introduction part. So the commonly used biomaterials are stainless steel 316L, titanium alloys, cobalt, chromium, molybdenum alloys, but the most commonly used, but the most extensively used material is the stainless steel, just because of good mechanical mechanical property, high strength, good corrosion properties, and low cost and ease of availability, and the good biocompatibility in the physiological environment. So these are some basic applications where we use implants such as hip implant, knee implant, and these prostheses. And so based on the literature survey, these are the literature survey where we've gone through, and based on this we have found a research gap, and based on the research gap we have concluded, we have pointed out some objectives such as fabrication of selective laser melted stainless 316 alloys and its microstructural, mechanical, and wetting behavior of the fabricated parts. So selective laser melting is a powder bed fusion system here, in which here we use a laser beam which is used to melt the thin layer of precursor powder in layer by layer manner to form the 3D parts. Here you can see also in the figure number 2, a directional laser beam scanning is done so that the so that the surface so that the formed surface should be more dense, And then in the figure number 2b, you can see that the sample is formed a layer by layer manner and in the building direction. It helps, it concluded the number of cool tracks, cooling rates, and the thermal gradient. And the thermal gradient and the cooling rates are helped in the building direction to use to produce the surface morphology, pores, and dendritic size. So in the present study, we use a selective laser melting technique with the laser power of 120 watt and the scanning speed was 1000 mm per second and the layer thickness 30 mm. And we use a 67-degree rotational scan, bi-directional rotation scan. These are the results. Firstly, we have gone through the ABHD analysis to see whether it is formed layer by layer. So here we can see that figure number 3a, the fine microstructure has been formed in the selective laser melted part, and it is formed by layer. And you can see also this sample is formed in the 67 rotation scan. So this fine microstructure helps to improve the mechanical properties. And in figure number 3c, you can see the 3D surface topography of the sample, which is taken by a 3D or non-contact 3D profilometer. And figure number 3D is the 2D surface roughness profile of the same. So from figure number 3c and 3D, we can see that the sample which forms a 67 rotation degree angle, and some of the pores and the boiling phenomena can occur at the top surface of the sample. Next, surface morphological and microhardness measurement. Surface morphology was done using the FESCM method. So here you can again see that the top surface shows a deposited powder layer, and the sum of the unmelted metal particle and which is accumulated over the top surface of the profile increases the surface roughness and will help to increase the wetting behavior. So the surface roughness of the formed sample was around 12 micron, which is in line with other selective laser melted samples. So, and the mechanical characterization was done using the Vickers micro hardness measurement, and we compared the hardness value of the selective laser melted part with the conventionally casted melted part, so that we can know what increase what was the value. So here in the selective laser melted part, the hardness value comes around 290 to 300 HV, and the casted part it was around 180 to 190. Sorry, the measurement was done at 50 gram load and
Aditya, you have last 2 minutes.
Okay, sorry. And the last characterization was a wetting behavior. Wetting behavior was done by using a two different liquid such as DI water and the HBSS. HBSS simulate the upper body fluid. So the selective laser melted part shows the hydrophilic wetting behavior with the HBSS and DI water, and the more affinity towards the HBSS. So we can say the selective laser melted part can be used as a biometallic implant material. So these are the conclusions. Here we can see the samples are made in the 3D part, and the 3D surface topography and morphological study shows that the sum of the boiling phenomena at the top surface, and the EBHD result and morphology shows that the sample consists of fine microstructure which increases the micro hardness value, and the wettability of the selective laser melted sample shows that the contact angle values ranges in the 59 to 86 degrees centigrade, degree, and shows the more affinity towards the HBSS as compared to DI water. So these are my findings, and I hope I completed on time. So thank you so much, sir. And if any question is there, please ask.
Yeah, thank you, Suryank. So I request Sudhanshu sir, if having
Suryank, yes. Suryank, do you have used the 3D surface topography of that? Which equipment that is?
This is just Dico 9000 new view series.
And whenever you go for a micro hardness tester and for indentation, what is the applied load in this case of indenter, diamond indenter?
In my case, I use the 50 gram load just because of the layer thickness
It
was
is
50 micron.
okay.
So I use the 50 gram load so that I can measure in every layer of the micro hardness value.
And what is the procedure that for a sample preparation for a microscopic observation in scanning electron, whether it will be 3D surface topography?
This after the fabrication, we cut the sample through iridium, and we prepare the sample by using the silicon carbide grade size paper ranging from 600 to 2000.
Okay.
After
That's
that,
correct.
we use the
That's
diamond.
fine.
Okay.
Thank you.
Okay, thank you, Suryank. And our also has a question at Praveen sir. So Praveen sir, are you having any question?
No, sir, no question.
Okay, thank you, sir. And thank you, Suryang, for your nice presentation. Now I request Mr. Aditya to kindly please share your screen and present,
Yes,
and also request all the presenter kindly please switch on your video, because it will required for capturing some of the glimpses which is required.
sir. I think my
Yeah,
screen
it
is
is.
visible, sir.
Yeah, both are visible and audible.
Yeah. Good morning, everyone. I am Aditya SV. I am here to present on a state-of-art review on implementation of digital twin in additive manufacturing to monitor and control parts quality. So, list of content, like we will be getting into introduction, representation of digital twin implementation, state-of-the-art literature review on the theoretical viewpoint and practical, followed by conclusion and future research directions. And day by day we are witnessing that AM is expanding its own way in the manufacturing industries, and in the support the technologies like cloud, IoTs, and big data analytics and digital twin is supporting these and integrating for a betterment of this process. When we speak about this DT, it is like a young research area in the present world, and the DT is nothing but the virtual representation of the physical product or the process for the study of its changes or else improving its qualities. So till date, again we will be to overcome the issues, some of the issues in the additive manufacturing of the quality issues. The DT is very much useful in the integrating in additive manufacturing. So in this paper, we will be firstly representing our represented the digital twin implementation in additive manufacturing. So representation in this implementation of DT, we classified, or we took a 4 major parts, that is of the AM machining, AM machine, big data analysis, and DT models, and AI algorithms. The what is this AI algorithms, or else in this firstly we will go with the DT models. DT models will be consisting of major 3 parts, like mechanistic models, control models, and statistic models. The control models are linked to various sensors to monitor the geometric features, and the mechanistic models is used to assess various properties from the metallurgical viewpoints. The statistical models where it is used to correct the errors made by from the mechanistic models. Some of the errors will be calculated and made corrections by the statistical models. In this process, again we will be having an big data analytics. Big data analysis tool is getting attention for as the process go on, the data's collection will be getting increased. So this big data analysis getting capability of massive assemblage of the various types of digital data. So these data are classified using these AI algorithms, and it gives a quick responsive. It helps in giving the quick responsive on the predictions for any errors occurs. Again, when we look onto this table type of data sources and data, what these sensing, what are the type of data we are required for maintaining the quality in the additive manufacturing. When we implement the DT, into this additive manufacturing, like sensing, testing, simulation data, literature, design, and sensing data come from the is collected from the IoT, and it's coming where it is directly connected to the AM machine. Testing results from the existing component test, and simulations are coming from the continuous mechanistic models will be getting into simulating the process. So literature database literature is nothing but the primary data which is input given input for an AM machine. And design is nothing but the CAD model or the geometry drawing or design of any product. Next we after analyzing some of the literature, we took a few literatures and classified them in the theoretical viewpoint and practical viewpoint. We can see this 5 to 6 papers of in the theoretical viewpoint of KO. It all presented the theoretical view on DT technology. He has analyzed the process structure property and he is related to and he related AM, and he set some AM rules. Actually he took an what he proposed a framework for an goal-driven top to bottom frameworks, or the data-driven bottom to top analysis. And Salma et al. Presented an IoT system. He has explained very well of the how
more 1 minute.
integration of, sir.
More 1 minute, kindly please.
Yeah, sure. So
Last 2
they
minutes.
are the theoretical viewpoints, and when we come into the practical viewpoints, this Chitri et al. And Wang et al. They consider the IoTs and cloud platform for an AM manufacturing resources to improve the efficiencies, and they have simulated, and they have calculated how efficient this DT will work on the AM processes. So conclusion and future research direction, when we based on some literatures and authors found little progress of efforts on developing implementation of this DT in the area of monitor and control the parts quality. So there are we found some of the challenges areas in implementing of DT, like DT requires closed loop process control, like the bidirectional communication is very much important in the DT. So it's a challenging area in the implementation in the AM processes. And real-time digital representation of physical domain required to in AM monitor, predict, and control process security, because of continuous dynamic changes occurring in the AM processes, collecting those data and continuously processing those accurate data are a little bit difficult, or it's a challenging task in the AM process. And implementing startup, as I said, DT is in still an younger phase of the research, so standards are still in a developing stages. So standardization and interpol definitions on integrating in industrial and cyber physical manufacturing is one of the again challenging area. Machine to cloud communication in AM systems are typically not clearly cloud they lack the systematic method of integrating various sensing intelligent decisions. So hope I got an precise.
Thank you, Aditya, for your presentation on implementation of digital twin.
Yes.
And so I request Sudhanshu Das sir, is having any questions or any doubts. Sudhanshu sir.
Mr. Aditya, tell me what are the different nowadays polymer based or metal based additive manufacturing is which is convenient for
Sir?
Nowadays there is a two different 3D printing or additive manufacturing based has been developed, that is a polymer based and the metal based. So which one is more convenient to practical application?
Like powder based selective lasering, sir.
Okay, sir.
So you are saying, okay, sir. So you are saying the powder based is more important for the additive manufacturing.
Yes, sir, because metals again when we come to a metal manufacturer,
my last question is, if you want to increase the strength of the additive products, what would you do?
additive products, sir. So sorry, sir, I didn't go too much depth in this.
Okay, thank you.
Thank you, sir.
Okay, Aditya, it is your review based work, or you did research some of on this?
Yes, sir. Actually, we gone for a review based work on just a digital twin, how to implement this digital twin into additive manufacturing process.
Okay. Okay, thank you, Aditya. No more questions is there. So kindly now I request Mr. Sesadev Barik, kindly please start your presentation.
Mr. Parik. Your screen is not visible.
Yeah, it is visible now. You just come in the first slide.
Sir, it is visible.
Yeah, it is visible, and also request you kindly please switch on your video.
Time is 10:30. Please conclude by 10:28.
Good morning. Good morning to respected session chairperson ICMMIT 2022 and all other presenters. I am Sesadev Barik, and this is my topic: effect of temperature and mechanical properties of zirconium nanowire using MD simulations. These are my list of content. Then introduction. First, what is nanomaterials? Nanomaterials are the materials which has at least one dimension. Has at least one dimension have size less than 100 nanometer. Nanomaterials are so interesting and have several advantages over bulk materials such as huge surface to volume ratio, more energy efficient, and completely different physiochemical properties. Also, there are important roles in the design of new materials for energy storage, sensor, electronics.
Prasad, please skip this thing and go to your each slides. Okay, I'm not visible your slides.
Sir?
So Sudha, just do one thing. You just stop sharing, and once you just share, because I think some network issue from your end.
Please close your video.
Just unshare. After that, again, just share. Okay.
Yeah, now try it.
Sir, now this is showing.
Yeah, just it is opening.
Yeah.
Then
Yeah, just make it in slideshow mode.
Yes, you carry on.
sir, there is some problem on the Linux version.
Okay, you can carry on. No, not an issue. You can carry on.
For this research work, I used molecular dynamics simulation. This molecular dynamics is a Grether method to study the properties of materials and see how molecules are moved at atomic level. These powerful tools can be used to predict material properties in nanoscience and to model biomolecules, to model drugs, vaccine, and much more. It is basically an experiment inside the computer and usually used when real-world experiences are become too expensive, too time-consuming, and almost impossible to do. This simulation typically needs 3 steps. Firstly, create an initial state, and then we introduce interaction potential between particles in the system, and at the end we predict how particles move by interacting Newton's equation of motion. This is the equation Fi equal to negative gradient of potential energy, and from the trajectory at the of the atom we determine different properties of materials. Hence, the interaction between the atom and molecules are calculated using interacting potential. So the selection of correct potential is very important. Then next, there are 3 types of atomic potential in molecular dynamic potential: pair potential, mono-body potential, and bond order potential. The right side figure shows for which type of materials which potential is choosable. Then since our zirconium metal is an anisotropic metal, so I used 2nm MEM potential for the simulation work. A modified embedded atomic model is an extension of original EM potential. In MEM, total energy of a system atom is given by this equation. The 2nm MEM model is an extended form of MEM model, which is better model while dealing with the metallic bond. This is the flow chart of MD simulation. Then simulation of zirconium bulk and zirconium nanowire. The initial atomic configuration of zirconium bulk and zirconium nanowire was arranged with ideal SCP lattice with lattice constant 3.20 Armstrong. And in this study, the 2n MEM potential suggested by Kim has been used to simulate the pairwise interaction between zirconium atom. For constructing bulk zirconium, periodic boundary condition is applied along all directions, but in case of nanowire, the periodic boundary condition is applied in one direction and other 2 directions are shrink wrapped. These are my result and discussion for uniaxial tensile stress along z-axis. This is the formula for calculating the tensile strain along z-axis. This is my formula, and from these 2 formula we can draw stress versus strain graph for bulk zirconium at fixed temperature and strain rate. This graph represents the stress strain curve at 300 Kelvin for 0.0005 picosecond inverse strain rate. From the linear region of stress strain curve, we calculate the Young's modulus. Here we get the Young's modulus for bulk zirconium is 101.95 gigapascal, which is nearest to the previously experimented calculated value 96.90 GPa. So we can say that this 2 nm can be used to demonstrate different properties of zirconium nanowire. Here this is the snapshot for SCB zirconium nanowire different strain rate. First, A represent initial state when strain value is 0, simultaneous B, C, D represent tensile state, necking state, and fracture state respectively, and corresponding stress versus strain graph is shown in the right side slide. Region 1 is the elastic region, region 2 is the plastic region, region 3 is the fracture region. To investigate the temperature dependence of mechanical properties of zirconium, we performed a series of empty simulations for various temperature ranging from 10 Kelvin to 700 Kelvin, a strain rate of 0.0005 picosecond, which is shown in this graph, and the table here represent the temperature effect on the mechanical properties of zirconium nanowire. Then finally, my conclusion: the mechanical properties of zirconium nanowire are found to be significantly temperature dependent. Here we get both elastic and plastic properties are temperature dependent. It also observed that the Young's modulus and ultimate tensile strength of zirconium nanowire decrease with an increase in temperature. So we can say that the strength of the zirconium nanowire decrease with the rise in temperature. Then finally, the loss of ductility is seen in the zirconium nanowire with increase in temperature. This is my so thanks. I would like to thank IMIT University, Jharkhand, India, organizing ICMMIT 2022.
Thank you, Seshadev, for your precise presentation on the temperature of mechanical properties. Now I request to Sudhanshu sir, if any question.
Seshadev, you just tell me how you can confirm that the reliability or repeatability of the result is correct. That you have. Do you have followed any standards to consider that for measurement or for any?
Sir, the experimentally calculated value is for zirconium, bulk zirconium is 96 gigapascal. By this is calculated by XRD value, and the.
No, my question is that how you can confirm that whatever the results that you have considered or plotted in your different graphs, is it a good repeatability of or precise, you can say?
Yes, sir.
Do you have, suppose I am going to the stress strain curve in this year. Yes, so do you consider any standards of measurement? Follow the standards of measurement? Definitely you have followed, but you don't, you might have not idea.
Sir, okay. I can't get your question actually.
How many experiments did you completed to find out the values?
Sir, I use the stress versus strain curve by using given two formula.
No, you have calculated the value of stress strain by using the formula. But what are the experimental values? Is it correct or it's just a theoretical paper?
Yes, sir. Some researchers
okay, thank you. Thank you, sir. Okay.
Yeah, thank you, Seshadev, for your nice presentation. Now I'd like to request Dr. Samadhan G. Morkhade, sir, to kindly please start your presentation.
Yes, sir. Thank you. Yes. Good morning, respected session chairs, organizers of ICMMIT, and all the participants. Sir, time is
10:38. 10:38. We are going to stop you in next 8 minutes.
Yes, sir. Yes, sir. Sir, is my screens are visible, sir? PPTs.
Yes.
Yeah, it is visible.
Yes, sir. I am going to present my topics on a parametric study of trapezoidally curvated wave. These are the contents of my presentations: introductions, literature review, research gap, objectives, parametric study, conclusion, and references. as we know that there is the corrugated wave beams are the advanced version of our regular plane wave beams. In case of a regular beams, the wave is the plane, but in case of a trapezoidally corrugated wave, this is the fabricated type of beam. It is not prepared in the industry. So the wave and flanges, they are welded together, and the strain capacity has been enhanced over the regular plane wave beams. These figures explains the step-by-step fabrication procedures. This is the bottom flange. This is the corrugated wave. Okay, this wave has to be prepared by according to the different angles of corrugations. Then, if sometimes we have to pass some utilities like some pipes through this wave, then we have to provide such type of openings in the waves, and this is the final products. Okay, and this is the final products of trapezoidally corrugated wave beams. This is the literature review. As a time being, I am going to skip this literature review parts. Now coming to the research gaps, a lot of studies have been made by different researchers on the regular plane wave beams, but the study on the corrugated wave beams is limited. And again, in that angle of corrugations influence the behavior of such type of spatial beam. So my study is that I have verified its ultimate load behavior by changing the wave corrugation angles. This same as objective, and again it is a fabricated wave beam, so that thickness of wave is a very governing criteria. So normally the thickness of wave is 3 mm, 4 mm, or 5 mm. So we cannot go for more than 5 mm because it will create a fabrication problems. Coming to the parametric study, the parametric study has been carried out by using the finite element software ANSYS version 12. This is the summary of my FEM models that shell 181 elements has been used from the ANSYS element library, which is having 6 degrees of freedoms, 3 rotations and 3 translation at each nodes. Nonlinear stress strain curve has been adopted, that is bilinear stress strain curve. Structural steel grades of
Dr. Samadhan.
Yes, sir.
Dr. Samadhan, your
Yes,
slide
sir.
is not scrolling. Kindly please scroll the slide.
You are still in the first page.
Yes, sir. Sir, I will skip that PowerPoint mode. I will share in the normal modes. This is the FEM models model in ANSYS softwares having the different corrugation angles. This is for the 3 mm wave, 30 degree angle of corrugations. Then these are the results I have got in the ANSYS. These are the 7 models have been analyzed in ANSYS softwares. The first one is the PB. PB stands for plane wave beams, means the wave is plane, no corrugations. Span of all the 7 specimens is 2 meters. Then from 2 to 7, the angle of wave corrugations has been increased from 30, 33, 36, 39, 42, 45. And for these specimens, the load carrying capacity has been compared. So this is one is with stiffeners, without stiffeners. Okay, actually this stiffeners is no point, because if we are using the corrugated wave beams, the strain capacity is already enhanced, so no point of stiffener is there. So for without stiffeners, if observe this table, increase in load carrying capacity for plane wave it is 61. As soon as we are increasing the angle of corrugations, the load carrying capacity is increases, whereas the corresponding deflection is going to be reduced. And this last column shows the percentage increase in load carrying capacity. And the same graphs has been plotted in terms of a load deflection behaviors. These are the 4 cases: corrugated wave beam with having stiffener 3 mm 30 degree, then without plane wave beams.
Last 2 minutes.
Yes, sir. This is for first graph is for 30 degree corrugations. Next is for 33. Then similarly 36 degree wave corrugation angle. Then 39 degree corrugations, 42 and 45. These are the parameters have been varied in case of a finite element analysis. This figure shows the deform shape, one mass stress distribution and deform shape of such type of a spatial corrugated wave beams. As the load has been applied at center of the beam, the maximum stress concentration occur in these regions. So last part is the conclusion. From the conclusion, the strength of trapezoidal corrugated wave beam is more than traditional beam with very little deflection at midspan. In many cases, which have been studied during the research work, that 45-degree angle of corrugation gives better load carrying capacity. Therefore, from fabrication point of view, it is recommended go for the 45-degree angle of corrugations. These are the references I have referred during the research works. Thank you.
Yes, thank you, Dr. Samadhan, for your presentation. Now I request to Dr. Sudhanshu Das if having any doubt.
Dr. Samadhan, I just want to a query about that.
Yes, sir, please.
What is the thing if you increase your correlation in a different angles? What you have observed? Because I have seen that it is increasing with that.
Yes, sir. Yes, sir.
So, what is the effect of corrosion, degree of corrosion in this case of that?
Yes, sir. Many researchers have studied only 2 degree of angle corrugation, 30 degree and 45 degree. So my intention is what that I have just studied the effect on load carrying capacity and deflections if angle has been changed from in the interval of 3 from 30 to 45. So that angle, as soon as we increase the angle of corrugation, the load carrying capacity of the sections is increases, and 45-degree angle of corrugation is found to be best one, sir.
That means corrugation is improves the strength.
Yeah, yes, sir, yes, sir. But not beyond 45 degrees, sir.
Okay.
Maximum is 45.
Okay. So what is the reason?
Yes, sir, yes, sir.
What might be the reason?
Sir, it increases the load carrying capacity, and that stiffness requirement has been minimized. Means in normal beam we require stiffness. In this beam, stiffness are not required, sir.
Okay, okay, okay.
Thank you, sir. Thank you.
So Praveen sir, are you having any doubt? Praveen sir, Dr. Praveen,
No
sir?
questions, sir. Thank you.
Thank
No,
you,
sir.
sir.
Thank you.
Yeah, thank you, Dr. Samadhan, for your presentation.
Thank you, sir.
And now I request to Mr. Sumit Kumar Gupta, kindly please share your screen and start your presentation, and kindly please go to the time limit at least.
Okay. Yes. Good afternoon, sir. My screen is visible to all.
Yeah, Sumit
Yes.
sir, it's 10:46. In next 6 minutes, I'm going to ring a bell. Okay.
Okay, yes, sir. Okay, good morning to all of you. My name is Sumit Gupta, and I am a research scholar in CSE department from ICMMIT Bhopal. And on behalf of my co-authors, I am going to present my paper whose title name is New GPU Shorting Algorithm Using Shorted Matrix. These are the list of content. We start with the introduction, literature review, goals, proposed algorithm implementation, followed by result, conclusion, and references. So we start with introduction. So what is shorting? So if we have a given a list of numbers, so we have to arrange the number in a shorted order where the smallest number comes first and followed by the larger number. So there is a cone who proposed the finding the exact position of each element in a shorted list by comparing the frequency of the element having smaller values. Like that, if there is a p element which are smaller than the aqth element, then the aq occupy the position at p+1 position in the shorted list. So it can be, it is an example of enumeration sort. So with the help of shorted matrix and enumeration sort, we try to short our list. So these are the literature review. Many examples are available in the literature in which sequential algorithm are modified to parallel algorithm by incorporating data level parallelism. These are some examples. So what is our objective and goal? So our goal is to propose a GPU-based parallel shorting algorithm which would work on the row and column-wise shorted matrix, taking the advantage of its property, or to find the actual position of every element by making minimum number of comparison. So our objective is to use the GPU, fully utilize the parallelism. So this is our proposed shorting method. So our proposed shorting method is, initially it the list is converted into two-dimensional matrix. After converting this list into two-dimensional matrix, we sort the matrix into row-wise and column-wise. So matrix exhibits some property. So this is the property. So if our matrix is sorted according to row-wise and column-wise, and if we have a current element which is shown in red color, so it automatically tells that the quadrant 1, which is shown here, is all the element of this quadrant is smaller than the current element of that matrix. and the fourth quadrant, all the element of this quadrant is the greater element from the current element, because this matrix is already sorted in row wise as well as column wise. So all the element before occurring that element are already smaller than that element, and all the element occur in fourth quadrant are smaller. So our concern is the third quadrant and second quadrant. So this is the example how our list is converted into the two-dimensional matrix. If we have a n number of element, then we have converted this into the two-dimensional matrix where our number of rows is, if suppose we have a number of row is k, then we have n by k number of columns. We try to make the matrix into square matrix. So as I already told about that, we have to concern about quadrant second and quadrant third, because quadrant first and quadrant fourth is already sorted. So our proposed algorithm is divided into basically two steps. First step is to divide the matrix into, to divide the list into two-dimensional matrix. After dividing the list into two-dimensional matrix, we going to sort the row and column. After sorting, we preserve the order of row which previously sorted, or this step is carried out into the parallel with the equal number of thread passes. This is how, if we have a two-dimensional matrix, so parallelly all the rows are sorted. After sorting the rows, parallelly all the columns of the matrix are sorted. After sorting these elements, the matrix is arranged like that. If A11 is the smallest element and A44 is the largest element, if we are comparing with any of the element, all the elements which are comes in the first quadrant of that matrix are smaller. All the elements comes into the fourth quadrant are the larger element. So our second step is to our aim is to count the, as I already said that we are trying to sort the matrix using the enumeration sort. Enumeration sort said that if we got how many number of elements are shorter from the current element, then we automatically get the position of that element. So our aim is to count the number of element having magnitude less than ijth element. So as we already say, quadrant 1 is smaller, quadrant 2 is greater. So we have focus on the quadrant second and quadrant third. So this is the step. If for any element ai,
Sumit, you have last 1 minute.
yes sir. So we are comparing why moving upward. If that element is the larger element, we move from horizontally, and if we got the smaller element, when we move upward to the, this is the case. Similarly, if we move on to the third quadrant and we got the sorted matrix, this is the our complexity analysis. So while sorting the array into sorted matrix, we required order of k log k, and comparing all the elements, we required order of root n. So overall complexity of our algorithm is order root n log root n. So this is the,
Please come to conclusion, sir.
okay. So sir, this is the our table. We perform our algorithm on 3 type of data set, and we got the 5% efficiency. This is the Gaussian, uniform, and bucket shot. So in this paper, we compare our algorithm with the CUDA thrust radix sorted algorithm, and we got the 5%, 5 times the our algorithm. These are the references. Any question?
Sudhanshu sir, any question from your side?
No question, sir.
Okay, no question from us, sir. Thank you very much for the nice presentation.
Thank you, sir.
Thank
Next
you,
is
Sumit. Now I request Professor Prashant J. Baggar, sir. Kindly please start your presentation.
Good morning all. Is my PPT visible to all of you?
Yes, sir, it is visible. And also kindly please make it in slideshow mode.
It is in slide mode. It is visible in slide mode?
Yeah, now it is okay. Fine, sir, fine.
Okay. So good morning all. So my topic is indirect toolware measurement and prediction using multi-sensor data
Sir,
fusion.
request kindly please switch on video. Please, if not really having any problem.
Hello. Hello.
Prashant sir, if possible, kindly please switch on the video. If not having any problem.
Yes. Is my video visible?
Yes.
Okay. So it is the topic is indirect toolware measurement and prediction using multi-sensor data fusion and neural network during machining. Just a minute, it is not changing. So these are my topics of discussion. So basically, cutting tool plays very important role in modern manufacturing industries, as we all know. And toolware is one of the important parameters that is being taken care of in industries. And toolware is normal phenomenon in the machining process, but it is determinant factor that affects the quality and tolerance of machine parts and also the cost of manufacturing. So measurement of toolware is important to estimate the useful life of the tool insert and economy of manufacturing process. So it will be helpful to monitor and study the effects of toolware on quality of the machine work surfaces. So toolware can be sudden or gradual. Mostly the tool life is correlated with the flank wear, which is a gradual wear, steady state wear. And in most of the cases, the flank wear is generally correlated to the tool life. These are the parameters that affect the tool life, tool wear, tool and workpiece material, tool shape, cutting speed, feed, depth of cut, cutting fluid used, and machine tool characteristics. So these are the different types of wear. So our project was focused on measurement of flank wear. This is the tool life that we generally have studied using Taylor's tool life equation. Now coming to the methods, there are two methods to measure the tool wear. One is the direct method and another is indirect method. Direct method, either we use optical microscope to measure the tool wear, or we use image processing and process the images of the tool wear region and then try to find out the flank wear. So these are the direct methods, but they are intermittent, and your machine is required to be stopped and then the measurement is taking place. Whereas in indirect method, there are physical parameters of the machines like force, vibration, temperature, surface roughness, which are then measured and then correlated to the tool wear. So I've gone through the literature review, and summary of literature review that since a single sensor cannot detect all the and collect all the responses in machining operation, multiple sensors are used to collect the responses. It is also understood from the literature that monitoring the condition of the tool is essential to achieve productivity during the machining. The work related to monitoring with multiple sensors is less. So this is need of research, optimum use of tool, and decreasing the cost and so on. So these are the problem statements, identifying the problem to automate the task of tool we are monitoring and optimization utilization of the tool. So sensor data fusion methods. In general, all tasks that demand any type of parameter estimation from multiple sources can benefit by the use of data fusion methods. So data fusion methods are the techniques wherein all the different physical parameters are measured simultaneously, and then the tool wear is estimated by correlating its values. So these are our experimental details. We have machine tool HMT Make CNC Turn Master, 3 kilowatts, 3000 RPM dry machining, and this is material EISI 4140 alloy steel with this size. These are the workpiece material properties and contents, and these are the tool that was used in this experimental work. Physical parameters was measured was vibration, cutting force, temperature. These are the experimental methodology. These are the parameters that were selected for the experimentation work. They performed 27 experiments using L9 orthogonal array of Taguchi method. The input parameters taken as vibration, temperature, and force for the parameter variables and output parameters or toolware. With the help of performance value graph input and output data are trained, validated, tested for the prediction of the toolware. The manually measured and predicted values of toolware through the developed neural network are presented in the next table. It can be seen from the comparison of the table 2 that proposed neural network model, is able to predict the value of the toolware with reasonable accuracy, and same can be utilized to monitor the toolware for continuous machining operation. So this is the details of the neural network, and these are the data that was generated during experimentation work. And this is the structure of neural network that was selected. This is the performance of the value graph. So coming to the conclusion, the different sensor signals behaviors were investigated in capacity of reflecting the measured process variable, namely flank wear. The main aim of the study is to provide the confirmed information for composing sensor fusion and using different sensors simultaneously to existing in indirect condition monitoring literature. Temperature and vibration signals appear to be compatible with the strong association with the flank wear. Cutting speeds appears to have a significant effect on both vibration and temperature, which serves as triggers for both. It has become essential in modern manufacturing industry to ensure high productivity and product quality. So the presented work experiments are performed on ASI 41403 with different range of machining parameters, and toolware was measured manually and predicted through neural network. So this was the beauty. So work presented is able to predict the toolware for the selected set of machining condition. However, with the change in machining condition, a more robust algorithm can be developed to predict the tool. So these are the references. Thank you.
Mr. Prasanta, that you have used a neural network. Is it how it is just like a black box modeling?
Yes.
So how you can confirm that the it is more better than the physical model? Physical aspects.
Physical aspect in the sense, sir?
Like we have plot the speed versus depth of cut, or speed versus vibration or temperature in this way. If you go to the database, you can plot in a physical aspects, but whenever you considering in a neural network base, as it is a black box modeling, so it is only feasible to predict if the parameter change beyond this range.
Because these parameters are taken for the particular range only, so they will be. These are the limitations that they will be only applicable to the range of parameters. Beyond that ranges, if it goes, then the neural network model will not be able to predict the toolware correctly.
Yes, that thing is fine. That is important. Okay. Okay. What are the in which way that you have measured the vibration? That is in the tool vibration or machine vibration? That
in the sensor, I have
in the vibration
on the tool hold. I have kept that the vibration measurement equipment was kept on the tool holder.
Okay, tool holder. Okay. And for the temperature?
Temperature, we had used thermocouple that was placed near to the cutting tool tip.
Okay.
As far as possible.
Okay. Okay. Thank you.
Praveen sir, are you having any doubt, any question?
No, sir. Thank you.
Yeah, thank you, Prashant sir, for your speech. And now I request to Ms. Komal Balaso Jadhav. Kindly please share your presentation.
Yes, sir. Yes, sir. Is my screen visible, sir?
Yes, ma'am, it is visible.
But not your PPT. Your desktop is visible. Yeah, now it is visible.
Okay.
Now it is visible. Yeah.
Okay. Okay.
So ma'am, it's 11:05. We are going to ring a bell at 11 after 8 minutes.
Hello, everyone. I'm Komal Balaso Jadhav. Today, I will be giving a short presentation on ultimate behavior of single-story steel frame with cellular beam using Tekla Structural Designer software. My presentation is divided into three main sections. Firstly, how to model and analyze steel structure in TSD software. Secondly, parametric study related to single story, single base structure with regular as well as cellular beam. Finally, result discussion and conclusion part on the basis of all observations. Beams with wave openings, commonly known as cellular beam, are extremely popular and versatile structural steel components. Cellular beams are often used to facilitate long spans, resulting in flexible, column-free internal spaces, reduced substructure costs, and shorter steel erection times. The goal of this research is to use TSD software to do linear analysis and predict the future behavior of a frame structure while changing the opening size in the beam. Here are some research papers which I referred while doing this paperwork. Let us come to the main point, stepwise modeling process in TSD software. First step is create and manage construction levels, and this figure shows the construction level dialog box in TSD software. Second step is create and manage architectural grids and grid lines. Third step is create and manage construction lines. Fourth step, create frames and slope. Fifth step, create dimensions. Sixth step is create beams, columns, and braces. Seventh step is create slab and decks. Eighth number step is validate the model. Number 9 is create load cases. And number 10 is manage load combinations. Number 11, applied loads. And last, run analysis. The last figure shows the green structure. The green color indicates all members are passed. Let us come to the next point, parametric study. We consider single-story steel building with bay size 4 meter by 3 meter, having clear floor height 3 meter, universal column with size 254 mm by 254 mm by 89 kg per meter is used. Also, universal beam with size 203 mm by 102 mm by 23 kg per meter for both regular beam and Weststock cellular beam. We use cellular beam with openings 100 mm, 125 mm, 150 mm, and 175 mm respectively. Design loads are taken from Eurocode Part 1, 2, and 3. Values are a dead load of 5 kN per meter, live load 4 kN per meter square, and superimposed dead load 1.5 kN per meter square. Tekla Structural Designer software was used to select the inbuilt load combination for strength 1.35 G plus 1.5 Q plus 1.5 RQ. First figure from this slide shows structure with a cellular beam, and second figure shows the structure with a regular beam. Structure's green color indicates all members are passed and withstands all applied loads. Now, after analyzing both structures in software, we will discuss the results produced from all observations. Table 1 shows the maximum deflection, major shear, major moment, and axial force versus various sizes of openings in beam. From the analysis, the performance of cellular beams was found to be very effective. This figure shows graphical representation of the maximum deflection, major shear, major moment, and axial force. Figures demonstrate visualization of maximum deflection in single-story frame structure. These figures demonstrate visualization of major shear force in single-story frame structure. These figures demonstrate visualization of major moment in single-story frame structure. And these all figures are demonstrate visualization of axial force in single-story frame structure. The conclusion part, a cellular beam steel structure with the circular aperture outperforms a structure with conventional beams in terms of performance. The maximum deflection of a steel structure with cellular beam of circular opening size 100 mm is decreased by 20%, and opening sizes 125 mm, 150 mm, and 175 mm is decreased by 40% compared to the structure with regular beam, respectively. The maximum shear force, major bending moment, and maximum axial force in columns of a cellular beam structure is slightly decreased when compared to the regular beams. Based on our observations, we may infer that cellular beams are superior to regular beams in single and multi-story structures. This brings me to the end of my presentation. I have talked about linear analysis and its ultimate behavior of single-story steel structure in TSD software. I hope my presentation today will be useful you to understand my topic clearly. Thank you.
Thank you, ma'am, for your nice presentation. Now I request to Dr. Sudhanshu Das, sir, if having any doubt or any query.
No comment, sir. No comment.
No
Yeah,
comment.
Praveen, sir, are you having any query?
No comment, sir. Thank you.
Yeah, thank you. And first of all, on behalf of ICMMIT 2022, I owe my deep gratitude to Dr. Sudhanshu Ranjan Das, sir, for sharing your precious time with us as a keynote speech and sharing the whole session 1 of first day track 2. Also, I am thankful to all the 7 presenters who have beautifully presented their research papers. I am also thankful to Dr. Praveen Singh, sir, for co-chairing the session. But last but not the least, I am also thankful to Lalit Bharadwaj, sir, for providing IT platform. Without this IT support, it was not possible. So thank you all the participants, presenters, and once again thankful to Sudhanshu, sir.
Thank you, sir.
Sudhanshu, sir, thank you very much, sir.
Thank you very much, sir.
And Sudhanshu, sir, once request, if possible, kindly please once switch on your camera.
Yes, definitely, sir.
Because we have not any photo of you.
Definitely, sir. I think
Yes,
video
thank
is.
you, sir. Just 1 second, sir.
Yes.
Sudhanshu, sir, one more request.
Yes.
We have a validatory session at 4:30, at 5, basically 5 p.m.
Okay.
If possible,
Definitely.
please join.
Okay.
Please join us and give your valuable feedback, sir.
Okay, definitely.
So, sir, I will share you the link
Okay.
of the session. So please join after 5 p.m., sir.
Okay.
Okay. Thank you, sir.
Okay, thank you, sir. And Lalit, sir, will be back by 11:35.
Okay. Thank you, sir.
Give me this back. Give me.
Sir, good morning, everyone, all the participants. Today we are here on the second day of ICMMIT 2022 in the second session, and we have with us Professor Shalin Kumar. Professor Shalin, before we start with the session of Professor Shalin, sir, let me just read out his brief profile. Professor Shalin Kumar is currently working at National Institute of Technology, Jamshedpur, and is serving as the head of Mechanical Engineering Department. Sir pursued his PhD from IIT Roorkee, and his research interest includes heat transfer, computer-aided design, and supply chain management. Sir has authored and co-authored numerous research papers in internationally recognized journals and has been a part of Sir has published several research articles in international and national journals, and he has been a part of various institutions. He has been in teaching since last 36 years and has guided several students. His achievements have been recognized by several awards, including the Distinguished Service Awards from Institution of Engineers, Engineers Achievement Award, and Plaque Felicitation in 2012 from Institution of Engineers. Sir is also member of several internationally recognized professional bodies, including Institution of Engineers, Indian Society of Applied Science, etc. So we are very Happy to have you here. Over to you, sir. Sir, kindly unmute yourself.
Yeah. Thank you, Abhijit. Thank you very much. So should I start now?
Yes, sir, you can.
Am I audible?
Yes, sir, you are audible.
So, okay. Is it visible, the screen?
Yes, sir, it is visible.
Okay. So thank you very much, Abhijit, for a kind introduction and nice word. I welcome all the participants in this session. Me, today I'm going to discuss a very important topic. We all, whosoever is working in the area of heat transfer, must have worked any day in the topic, that is heat exchanger. It is very common in all the life nowadays. We cannot avoid heat transfer and vibration in our life. If I'm a mechanical professional, then these two parameters cannot be avoided, or we cannot, rather say, we cannot neglect this heat exchanger and vibration. So since we cannot leave this one, we have to live with this one. We need a system, heat exchange equipment as efficient as, and similarly, if we cannot avoid vibration, our effort should be minimized as far as possible. So as far as technical or customary definition is concerned, it is used to exchange heat between two fluids at different temperature, which are separated by a solid wall. But it doesn't so simple. As far as difference is concerned, it is simply a heat exchange equipment where steam can be generated with the application of heat. So simple. Heat can be generated with the introduction of heat. It is ubiquitous to energy conversion and utilization. They encompass wide range of flow configuration. Applications are unlimited. As far as for counting is concerned, it can be heating and air conditioning, power production, waste heat recovery, food processing, sterilization, bio processes, and so on. So as earlier I said that it is, steam is generated most of the times with the application of heat. So boiling of saturated liquids in the presence of isolated bubbles are also find wide application. Boiling heat transfer equipment is frequently used in the process industries also, and at different temperature, different chemicals are separated from the raw crude oil, and in that application, it is known as distillation column. When crude oil are separated, different types of, so in that application is known as distillation column, or it is called reboiler. Most heat exchanger process, so there is no difference between reboiler and heat exchanger. Only in a particular application it is called like that. So most heat exchangers or process reboilers are of cell and tube in construction, and boiling may take place on either side of the, so it can be water tube or fire tube, whatever you want. Heat exchangers are classified according to flow arrangement and type of construction. These two words now is take care of this one. It is flow arrangement and type of construction. Later on, these two parameters are so complicated that we find very difficult to simulate. These are different configuration. So initially, there was no buffer. This insertion are there. Initially, these insertions are not there. These are called baffles, and baffles are used to establish a complete cross flow and to introduce turbulence. And that's why you might have heard fins are there, and now people are different type of baffles are used. Maybe hyperbola, parabola, some special type of cuts are being introduced,
to make it more efficient. And again, same configuration and so many parameters, temperatures are there. But as far as simple expression is concerned, the fundamental equations is this one. Is mass flow rate, Cp, and out and in. Since very easily we cannot write T in or T in out, or so average are being used, and in place of average we introduce log mean temperature difference. This del T here, since temperature of the fluid or whatever you can say, both media will go on changing, keep on from one end to another end. If from this end to this end or from this end to this end, temperatures will go on decreasing, changing rather I should say, temperatures are changing, and so this does not hold true, and in place of that we introduce this parameter. And whereas this log mean temperature difference can be this one, this is further long equation. Further I will find next time this further long equation. Now see how it is going to be complicated. Simple equation was del T, if it is MCP del T, but del T is now replaced with log mean temperature difference and this log temperature, and again here overall heat transfer coefficient. So these two parameters are very difficult to compute, and we are trying daily, and the researchers are doing how to make it simple, these two parameters. So when we talk about fundamental equation, this is for hot fluid, this is for cold fluid, and when we will combine, is this one. So usual design, being a designer, our objective is to determine the required area A for heat duty Q here. One parameter, and for that, these two parameters are very important, or we have to take care. Combine above equations, solve for A, need to determine U and Tm. This U and Tm is so complicated, we're forced to do something else. So heat transfer analysis of an heat exchanger is aimed out to relate, not evaluate, to relate heat transfer rate Q, heat transfer surface area A, heat capacity rate C, overall heat transfer coefficient U, fluid terminal temperature hot and cold, and the beauty is, or complication is, none of the above parameters are exclusively independent and have infinite value, and therefore the performance of heat exchanger is constrained. These are not independent parameters. So we have to perform a research in such a way that there should be trade-off between all these parameters. And when we are going to make a trade-off between 5 or 6 parameters, we know how complicated this system will be. A designer must make trade-off between the different operating parameters, like your heat exchanger should be compact, multipass. Why multipass? To make it more efficient. I mean, to have the heat transfer take place, to get the minimum, desired temperature, we need time. Heat transfer to take place, we need time. And so to provide time, multipass concept was there. So this multipass, how many pass would be there? This log mean temperature difference. Later on, since it is a crude value, it is later on a correction factor was introduced in LMTD, log mean temperature difference. In ideal, overall equation is this one. In ideal case, this del T mean can be, del mean can be log mean temperature difference in a simple in a simple case. But it is not so simple. Now this correction factor is there to evaluate del T mean. We have introduced, our people have introduced earlier this correction factor, and due to this correction factor, this equation is complex. This FT can be evaluated only when a variety of liquid surface experiments have been performed, and large amount of liquid surface combination factor. This is the detailed equation, parameters, detailed terms for the log mean temperature difference. And since so many parameters are there, it is very difficult to get exact value of log mean temperature difference. And so when we are accurately want to model or simulate the heat exchanger, we need alternative of this one. What could be the alternative? It is to be thought. The rate of vaporization in an exchanger is sensitive to available temperature difference because boiling heat transfer coefficient itself is a strong function of temperature difference. So now, in place of that one, we are started focusing how can be boiling can take place at lower temperature, so that its efficiency can be increased. In sense, if we say other areas here, see almost this is fixed. This is also for a particular combination can be fixed. Now this is a parameter where one can play. How we can play? Atmospheric pressure is fixed. As far as boiling temperature or is concerned, I mean most of the parameters are fixed. Here, to make it more efficient, effort was being made how we can start boiling to take place at lower temperature. And boiling start to a temperature, all these fins and special tubes were thought of. So continuing trends towards more efficient energy utilization require design with lower delta and less flexibility in hitting medium operating parameters. Exchanger performance is always limited by number of factors like critical heat flux, above which, and people ignored this one. People have ignored this. How it will come, we'll just discuss. Vapor blanketing, liquid surface combination factor, and heating surface operating parameters. These are the three parameters. If we have to ignore overall coefficient U and delta, then these parameters are required to be introduced in our research. Because of complicated nature of the boiling process, very complex calculations are required for a comprehensive design. Now we can see how so many parameters are required to be addressed, and a simple equation Q is equal to MCP delta becomes how complex. And the boiling heat transfer coefficient decreases sharply with decreasing delta. Therefore, the trend toward a smaller delta has prompted the use and further study of various types of enhanced boiling heat transfer that provide more surface and more bubble mitigation site at low T. Please take care of this sentence. This is the trend, how an efficient heat exchanger can be designed. Your effort should be how boiling can take place at lower temperature. And boiling to be nucleation to start at lower temperature, different type of fluid surface, I mean different type of heating surfaces have been introduced. Heat transfer from a heated tube within tube bundle is different from that of an isolated single tube. This is the boiling phenomena when take place on a single tube and a tube bundle. See, in this area now, efficiency of the tube bundle is going to increase. Here do your sensible heat and all this one is there, and then now here, since it is higher than this one, and so tube bundle is more efficient than a single tube. One can say that in place of making number of tube, why not I should increase the tube diameter for same configuration. But it's an experiment, but research has shown that tube bundle has higher efficiency, I mean higher heat transfer rate than single tube. And so people in place of single tube, multi-tubes are used. One reason is this one. Another reason is to make the heat transfer more effective, we need time. And when liquid is allowed to pass through different tubes, it gives the sufficient time. This is the phenomena where most of the people ignore this one. When boiling will take place, different type of boiling phenomena, different type of boiling take place in the system. And for each system, we have different governing equations. For each system here, interface evaporation, then bubbles, and after boiling, this film will take place. And this film after a certain period of time, it starts providing insulation rather than supportive to system. It becomes negative to the system, and we have to do something so that film should not take place. Maximum we have to go up to the stable film boiling. That's all. Even this it is not desirable. We have to stop here itself to have the maximum efficiency in this area. Though we have seen in the case of this area increasing, but this in area two-phase flow take place, and this two-phase, if it is not being controlled, blanketing will take place at the upper surface of the tube bundle, or you can say cell, which is not desirable. Again, different type of, if I'm not going to control the boiling phenomena, these are the, initially it is subcooled, then nucleation will take a start, and see these two type of, it started separation. It started separation, and due to that, we got negative effect. Agitation, particularly because of vapor within the bundle, increase the heat transfer coefficient in the nucleate boiling region, particularly at low heat flux. At higher value of wall superheat, the presence of large amount of vapor within the bundle causes vapor blanketing, what I earlier told. If boiling is not controlled, vapor blanketing will take place, and this will put negative impact on our system. So reboilers are now, what is the solution to avoid all these things? So heat exchangers or reboilers are usually designed on the basis of single tube. You see what we do in the industry. Heat is supplied in all the tubes at the same mass, same level. Power is same. Normally we heat the water, we supply the heat, I mean either through electric heater or through some other process fluid, and temperature in all the tube are same when we are going to provide. And this mistake is, you can say, I mean, this is playing the important role in our design, and vapor blanketing and all those things are due to that only. We normally provide same heat duty to all the heat flux. So what it should be, reboilers or heat exchangers are usually designed on the basis of single tube heat transfer coefficient. Experimental data, by considering a factor which is empirical in nature, this factor invariably accounts for interaction amongst the vapor bubble of the various tube rows of the tube bundle. In fact, the value of this factor remains constant without any regard to the heat flux, pressure, tube material, etc. This does not represents a true picture of boiling phenomena in a multi-tubular bundle with respect to pressure, heat flux, and other pertinent variables, as interaction of vapor bubbles occur at various tube rows vary from bottom to top. This is the importance here. Since we consider we supply same heat to all the tube, but what happens? Heat flux and other parameter variables as interaction of interaction of vapor bubbles occur at various tube rows. Let's say on the first, due to application on the lower tube, some bubbles that take place, and after that this bubble will, due to density, it will go up and it will hit the upper surface, and due to heating of this bubble to the upper surface, efficiency of the upper surface or condition of the upper tube will get enhanced and it will work. I mean, additionally, we are going to provide some heat. We will see from the some, and hence single heat tube correlation cannot be applied directly to the tube bundle, whereas all the equations initially we have seen, the fundamental equations are only of a single tube, whereas the boiling phenomena is different than that. A general correction factor to evaluate bundle boiling heat transfer coefficient has been given. This correction factor, this was given in 1980. Here, this is H1 heat transfer coefficient. H boiling, total boiling, we say, is correct. Here, these two are correction factors for boiling, correction factor for convection. So here it is H1 is before convection dominate, and this one is for the convection. So heat transfer equation should correlate, should be considered one factor before nucleate boiling starts, and this one when boiling starts. Before that and after that, and all these have this should be governed by the separate equation. It should be governed by separate equation, which is we do not do that, and so our efficiency is not what we require. Later on, the above correlation has been transformed as heat transfer, boiling heat transfer coefficient is equal to this alpha and beta, the parameter. H is nucleate boiling, and here it is two-phase boiling. Here H is nucleate boiling, it has another governing equation, and two-phase boiling equation, what type of boiling is taking place, and according to that, this equation should be modified. Whereas if we see earlier equation, normal equation is Newton's law of cooling is Q is equal to H A and del T. We do not have anything about this one. Q is equal to H A del T. It is not going to taking care these two parameters. An actual phenomena is this one. So boiling heat transfer coefficient through single tube heating surface, these are the parameters which has to be always taken care when we are going to simulate the heat exchanger. Whenever we are going to simulate heat exchanger, true picture will come only when we will consider these parameters. Heating surface combination factor is also a very important term. So liquid surface combination factor, operating parameters, boiling phenomena, boiling heat transfer coefficient through tube bundle. Whosoever is working in this area, please have a look on this one. Whenever you are going to simulate heat exchanger, you have to consider these parameters. Why it is important, I will show through some of the, let's say it is simple experimental result where heat is being supplied to a single tube or multi-tube or whatever you can say. In all the cases here, so many data or experimental data are there. Here you can say simply it is increasing. All the data simply it is increasing. Now, initially it is H is proportional to Q raised to the power N. H is proportional to Q raised to the power N. And when we remove the constant of proportionality, this parameter is C, and this is liquid surface combination factor. And now there is a debate between this N also, but most of the people have got this N is 0.7. Of course, there is a, these are the different values of N. These are the different values of N, but nowadays I'm at this moment, I'm not going to discuss this N. Now this is an experiment when two tubes are being heated. simultaneously. Now see what is the difference here. At this level, see this gap, and at this level you see the gap. Performance of lower tube is this one, performance of upper tube is this one. From this graph we can say that efficiency, or you can say upper tube is working at higher value to that of lower one, and that's why we use a number of tube. But at the same time, what is the difficulty, what is the problem we are facing? It is here both the tubes are being heated. See, heat transfer coefficient, when both tubes were heated simultaneously with same value of heat flux. Both tubes are being heated at same value of heat flux. So performance of upper tube is better than lower one. But see this gap is going on decreasing. When we introduce third, fourth, fifth number of tube, then this they might become same. The gap will go on decreasing, and we have to avoid that. Our effort should be, this gap should be maintained. This gap will be maintained when we will supply less heat to this tube than that of this one. It can be verified by some other next here. See, in this one, variation of heat transfer coefficient with heat flux of the boiling of distilled water when both tubes were heated simultaneously at different values of heat flux. In earlier one, both are being heated at the same value of heat flux. In this case, it is being heated at different value of heat flux. Now this is further decrease, and we have to avoid this. What will impact? Whether heat flux of the lower tube should be more or less. One should know what should be the temperature, what should be the heat flux, or what should be the power to supply at what temperature, or what it should be supplied. So next here, now see this one. This is the performance of lower heating tube, and these are different type. These are the heat flux. These are the lower tube operating at different temperature. When lower tube is at this wattage, here is performance is this one, and this one is this E. So as we are going to increase the heat flux of upper tube, its performance is going to reduce. And this happened in our most of the heat exchanger. Here, as see, when we are going to increase the heat flux of upper tube, its performance is going to slow down. This is when the heat flux of lower tube is minimum, and this is when heat flux of upper tube is maximum. So we can say that when upper tube has less heat flux, its efficiency is better. But what we do in place of this one, our actual phenomena is, see here, at lower than this one, this gap is this one, and when both are being heated at, see, this is the case, and it is going to narrow down. Whereas if we see this one, see this value, this one here, this line and this line, it is not going to reduce. So we have to have this type of system in place of this one. Most of the industry and most of the heat application, we are doing this one. Because all the tubes are being heated at same value of heat flux. And when we see this result, this is counter effecting, and so we should avoid this one. We should do like this. So heat flux of lower tube and upper tube should not be same. As we are going to higher number of tubes, in first row, heat flux should be something else. Second row, third row, fourth row, fifth row, it should be something else. Why? You can see this phenomena, why it is. This is the case. This is your lower tube. This is your upper tube. As we go and increase, more number of bubbles will be there. So your lower tube is being heated. When it is being heated, liquid, surrounded liquids get heated and boiling is taking place. Bubble will take place. So this bubble is going to strike this tube. When third tube will be there, bubble coming out from first tube plus bubble coming down out from second tube is going to hit the third tube. And similarly, bubble of first tube, second tube, third tube are going to hit fourth tube. And like that, efficiency of all the upper tubes are being improved. So this is the phenomenon. When boiling takes place at a tube row array, the bubble from the lower tube hits the upper tube and enhance the heat transfer coefficient of the upper tube. So when due to this bubble, this condition is going to be enhanced, we require less heat flux because this enhancement is a function of the heat flux of the lower tube, heat flux of the upper tube, and pressure. The enhancement will depend upon heat flux of the lower tube, heat flux of the upper tube, and pressure within the system. To be more precise, an enhancement factor can be coined as this example. Enhancement factor is heat transfer of upper tube with interaction and H upper without interaction. What will be the change? Here, heat transfer of upper tube when both tubes are being heated, and heat of upper tube when when it was working as alone, and this will give you the enhancement factor. By this, based on the above observation, a model is required to be developed to predict the heat transfer, predict the enhancement in the heat transfer coefficient of upper tube of a vertical row due to bubble interaction of lower tube. To represent the true phenomena of the boiling, this behavior is required to be undertaken in our research, in our consideration, our modeling. When we consider this one, so this effectiveness factor depends upon the heat flux of lower as well as that of upper tube. It increases directly with increase in the value of heat flux of the lower heat. Conclusion of 3 figures. It increases directly with increase in the value of heat flux of the lower heating tube, but decreases with increase in upper heating tube plus. You please consider this sentence. Upper heat transfer coefficient of, or you can say performance of upper tube increases directly with increase in the value of heat flux of lower heating tube, but decreases with increase in upper heating tube heat flux. So this can be experimentally, we can be written as this one. Upper tube, let's say upper tube at that particular moment has a virtual heat flux, and this virtual heat flux Q dash U is QU, its own heat flux, plus K into QL. Some amount of bubble coming from lower tube is going to strike, so this is K. Upper heating tube provides a higher heat transfer coefficient. It can be thought of as a single tube operating at a virtually enhanced heat flux. Therefore, upper heating tube can be regarded to have a virtual heat flux QU dash, which is greater than the supplied heat flux QU. Hence, QU dash can be expressed as Q dash U plus QU plus KQL. When I will write for second, then Q double dash U will be equal to QL plus QL plus KQL plus KQU. Here it can be like this, we can write Q double dash means heat flux of third tube will be equal to heat flux of lower tube plus heat flux of second tube plus some factor of lower tube and KQ of second tube, and it will go on increasing. It can be like this. Further, it can be here. With the experiment, it has been evaluated. Value of K has been evaluated. And this is equal to 13.7 K Q minus 21.5 minus 1. K is equal to here, this Q. Now heat flux of all the tubes are known to us because we are providing heat. Heat flux of all the tubes are known to us. Only unknown parameters is this one. It can be evaluated experimentally by performing this one. And I have also done that. And here in my case, I obtained K is equal to 13.77. Q raised to the power minus 0.215 minus 1. And when I use this expression, a tube bundle can be simulated. And any number of tubes we can attach with this one. Thus, by using above equation, one can obtain the value of virtually enhanced heat flux, but above equations are dimensional in nature. They cannot be employed directly from one experiment to another experiment. Therefore, a non-dimensional Nusselt number, Reynolds number, Prandtl number correlation is required, which may vary proportionally. And when we will use the non-dimensional parameters, any other researchers can use this one. One can say for particular equation here, one can say when it is in terms of, when I am writing in terms of this one in here, one can say that it is limited for, earlier I have seen the value of C, liquid surface combination factor. So this parameter may be biased with the liquid surface combination factor. To avoid that, one can convert this one, express this one in non-dimensional parameters in terms of Reynolds number, Prandtl number, and so on. And with this is one correlation. One may find some other one, but this one correlation has been, it works properly. Up to most of the times it works. So nucleate boiling of upper tube will be this parameter, Reynolds number 0.7, and this value has been obtained. This value, this value will again depend upon the different type of liquid surface tension, and this data can be tabulated by performing the experiments on different type of tube, material, and liquid. So this is your normal heat exchanger bundle. Now here Q is, this was L, L1, L2, L3, L4, L5, L6, L7, so on. It can be, and now accordingly this equation can be used.
Sorry to interrupt you, sir.
हो गया?
Sir, yes, sir, we are
यार तो अभी तो बहुत
running
कुछ
late.
बाकी है. Okay, I'm going fast. Okay, give me another 5 minutes. Give me another 5 minutes.
Yes, sir. Yes.
Can I do that, or I have to stop here?
Yes, sir.
Okay.
No, sir.
Okay. So now the actual phenomena is what we have to do. As I saw here, as earlier I saw that here actual heat transfer will be boiling plus convection, and for how to determine whether it is a natural convection or forced convection, these is parameters. And for different type of parameters, now I will not discuss this one. For different type of value of this one, these are the different equation. I will not discuss this one. What I will discuss now is, so one can model the heat transfer like this. See, this is your tube bundle. Here you are going to collect the vapor, but due to vapor blanketing here, you may not be able to find. But when we are going to simulate that here, at this region, temperature of the liquid will be more in comparison to these two, and due to this, circulation will take place. So here the tube is entering, it is get heated, it is converted in a steam. Here temperature will be less, and away from the tube again temperature will be higher, and so due to that, this recirculation, one has to model this one. This recirculation model has to be taken care. What we will do here, pressure at this point, we will equate the pressure. We will equate the pressure or pressure drop. What will happen here? This is the equation is this one. pressure drop between different type of leg, AB minus BC, it is going up. AB minus BC, AB minus BC. So here it is AB. I'm going to tell you here. It is A, B, it is C, it is D and E. A out at the extreme end, at upper extreme end, lower extreme end. It is at the near the tube bundle, entering of the tube bundle. It is coming out from the tube bundle, and it is the space where steam is going to be collected. So pressure drop, this from here to here should be equal to increase in this one. Or if it is going to increase here, then it should be, so sum of pressure drop between AB should be equal to this one. It has been like this, one can do that. Same thing is happened, but again, what is the difficulty is here, this is the equation. Pressure drop can be between all the parameters can be evaluated, and then, but what has happened here, demerit in this model is, since liquid, depending upon the density, it will enter from all the tube row, and so that should not be taken care. We have to, you have to consider that, I have to consider the system like this. I will have to forego all these things. All these things I have to forego. Your actual, this is the actual phenomena. Boiling, I mean liquid will come out or enter at each level. Here in the initially what we have considered, pressure difference from here to here would be equal to this much, but it should not be that, since depending upon the temperature, liquid will enter at each row, and so we have to consider the pressure drop from here to here, here to here, here to here, and same thing from each row. When we will do the same thing from the each row, then actual phenomena will take place, and that can be the your actual modeling. See, this is the equation now. From each tube row, it will, liquid will enter and will come out, and we will simulate this one from each level of the each tube row. This is the governing equation one can write, and the above constitute an improved model of heat transfer in a heat exchanger. It can be used to predict the value of mass flux, recirculation rate, void fraction, heat transfer coefficient at each tube row of the tube bundle, provided operating pressure, heat flux, and physico-thermal properties of the vaporizing fluid are known. So, okay, since time doesn't permit us, I'm going to stop here. Abhijit can proceed further, though I have another half an hour. Okay, no issue. Chalo, in future we will talk.
Thank you, sir. Surely we will.
So once again, whosoever is working, please simulate assuming you're like this. This is the actual phenomena. So liquid will enter as each tube row, pressure drop across from here to here should be equal to like this. Okay, fine. Thank you. Thank you.
Okay. So we will be starting with our sessions, technical session. So we would request you to be the session chair of that technical session, sir. So in this session, we will be having 7 presentations. Okay. And you can see the name. We will be having presentations of Dheeraj, Kirti, Shuvarnil, Anita, Sheshaya, Madiha, and Sonu. So I request all the authors to please stick to the timings. So you need to present your work in 10 minutes. You need to present your work in 10 minutes. 8 minutes will be there for your presentation and 2 minutes for question answer round. So you will hear a bell at 6 minutes. That will be a warning bell, and you will have to conclude in the next 2 minutes. So you'll hear another bell at 8 minutes, and that is the time where you need to conclude your session. And the rest, next 2 minutes will be for question answer round. So let us start with the technical session. So for the first presentation, I would like to call upon Dheeraj Deepak Ahiwale. Sir, you can start sharing your screen.
Okay, sir. I'm audible to everyone, sir?
Yes, sir, you are audible. You
Okay,
can
sir.
start sharing your screen.
Sir, is it my screen visible?
Yes, sir, it is visible.
Okay. So, can I start, sir, my presentation?
Yes, sir, yes, you can start.
Okay, sir. Good afternoon, everyone. I'm going to deliver the presentation on modal analysis of crack cantilever beam using ANSYS software. These are the contents of my presentation. Introduction. So most of the structures are subjected to degenerative effects, and that may cause the starting of the cracks, and that cracks may lead to the catastrophic failure of structure. And due to the discontinuity of cracks, the assembly of the most engineering structures are difficult, and that crack may concentrate the stress, and that stress concentrate creates the changes in frequency and also the change in mode of vibration due to the local flexibility. And most of the cantilever beams are generally used in high-rise structures, bridges, buildings, stadium, and many more. And such cracks, single cracks in cantilever beam, that may cause the catastrophic failure. So to check the modal behavior of such structures, the finite element approach is a best approach. So there are different types of cracks may occur in structures like shear crack, flexural or tensile, and combination of shear and flexural cracks, or a use of insufficient reinforcement in concrete or corrosion in concrete. So also the manufacturing process. So during such cases, the cracks may develop, and that may change the modal behavior of structure. So such effects of cracks on cantilever beam that may change the stiffness of beam, natural frequency, and mode shapes. And due to the change of dynamic properties, the failure of structure may occur. So there is need to study the dynamic behavior of structure. So I have done some literature review regarding the modal analysis of crack beam structures. And from that literature review, I have found that the research graph from this study is the study has been performed on uncrack and crack cantilever beam using ANSYS software, but limited study has been performed when crack is provided at different location. Also, the crack depth is also provided on different surface of cantilever beam. So objective for this study is validation of theoretical and numerical results of uncracked beam, then parametric study of cantilever beam with and without crack at different location and at different surface by using ANSYS software to know the dynamic properties of structure like natural frequency, mode shapes using ANSYS software, and comparison of uncracked and cracked cantilever beam. The methodology used for this study is first one is theoretical analysis of uncracked beam has been performed, then modal analysis of uncracked beam using ANSYS software, and then the parametric study has been performed for different location and different surface crack. The geometrical properties considered for this study is the length of beam is taken 3 meter, width of beam is 0.25, depth is 0.2, then the crack depth is 0.1 and crack width is 0.002 meter. The material is taken mild steel, Poisson's ratio is 0.3 and elastic modulus is 210 GPa, density is 7,860 kg per meter. In theoretical analysis, first of all, the natural frequency has been found by using this equation 1 from the Pickley book. So in that, the lambda value has been taken from this book for first 3 modes, and by putting the lambda value and the geometrical properties and material properties, the natural frequencies has been calculated for first 3 modes. Then in ANSYS software, the modal analysis has been performed to know the natural frequencies and mode shapes. So for that, the mathematical model has been created by providing the geometrical properties in ANSYS software. And for getting the accurate results, theoretical results, the hexagonal meshing with The elements has been increased up to 2625 and node numbers 13,480. And here the below figure is showing the cantilever beam having one end is fixed, other end is free. So results of uncracked beam, first three modes has been checked, and the natural frequencies for first mode is 18 hertz, second mode is 114 hertz, third mode is 309 hertz. So which is approximately similar to the theoretical results when we compared with the model analysis results has been performed in ANSYS for first three modes. So same modeling approach has been we have considered for parametric study, and we have taken the cracks on top, middle, and bottom surface at location of 0.5, 1.1, 1.52, and 2.5 meter from the fixed end, and the crack dimensions has been taken constant for all locations of depth 0.1 meter and width of 0.02 meter. So these are the some models which are showing the cracks is provided on top surface, at middle surface, and at bottom surface. The results of the crack is provided on top surface at 0.5 meter. So this is for mode 1, mode 2, and mode 3. So it has been observed that when the crack distance is increases from the fixed end, the frequencies are also increases. So the distance is having lesser from the fixed end. So that time the natural frequencies are reduced. That is the modal dynamic behavior. Similarly, when crack is having at 1 meter location, so this is the modal behavior of structure for mode 1, mode 2, and mode 3. Then for crack is having at 1.5 meter, this is the mode shapes.
Mr. Dhiraj, you have another couple of minutes to conclude.
Okay, sir. So these are the pictures I have included here for different surface cracks, top, middle, and bottom cracks at different location. And this is the mode shape behavior. And from these results, I have observed that the frequencies are initially decreases when crack location is near to the fixed end for top and bottom end. When crack is provided at middle end, there is no change in the frequency. The frequencies are constant for mode 1. Similarly, for mode 2, the crack is decreases and increase in nature for top and bottom. For middle, there is constant behavior. And similarly, for third mode, there is increase, decrease, increase, and increase behavior of natural frequency for top and bottom. So this is the comparison of results for mode 1, mode 2, and mode 3 for top edge, middle edge, and bottom edge. So from this study, it has been observed that the analytical identification, the natural frequency values are highly accurate in terms of obtaining theoretical values. And also the presence of crack reduces the natural frequency, and the amount of reduction varies depending on the position of crack, that is top, middle, and bottom. Also, the natural frequency of crack cantilever beam reduces when crack is provided on top and bottom edges of the beam, but when crack is provided at middle, the beam remains stable. Then the natural frequency changes slightly as crack shifts from the fixed to the free end. The next one is the mode shapes of crack cantilever beam depend on the depth and position of crack. And the last one is the effect of crack varied based on the mode of vibration. These are the references I have used. Thank you. So, any questions?
Thank you, sir. It was really a very nice presentation.
Thank you, sir.
Shailendra, sir. I think he's busy with some work. So, sir, I just wanted to know whether you have worked on varying crack length.
We have used same crack width and depth, but the location is different. Okay. Crack location we have used at different locations.
So you have chosen a V crack or a U crack for the study?
V cracks. We have chosen V cracks.
Okay.
Mr. Dhiraj.
Yes.
How you have introduced crack on your test piece?
So crack we have model.
Yeah, how you have introduced that?
So we have used the openings of that depth and width while modeling. We have used the throughout width of 0.002.
No, see, a cut has been introduced on your test piece, right?
Yes.
So how you have introduced that cut?
So in ANSYS software, sir.
Yeah, you have model, na?
Yes, sir.
Then how you have model?
Actually, this
Okay,
modeling
no
part.
issue. Okay, fine, no issue. So all the default values you have taken. Okay, no issue. So, but see, one thing you have to always take care.
Yes, sir.
When you are going to mesh, whatever the element you are selecting, you should
Yes, sir.
know justification of that one. Why you have 6 noded, 8 noded, 12 noded element has been selected. You have to justify that.
Okay, sir.
Because some default values are there, but we should not. Because then one can ask what you have done. Everything is available in the ANSYS.
Yes, sir.
Right?
Yes.
So I have to know why I am going to introduce this one. Why I have selected 8 noded, 16 noded, or solid any type of this triangular, whatever it is. So we have to justify that. And one more thing, you have to increase the density of the mesh at that particular where you have introduced the cut. The density of mesh should be higher than other places. That
Yes,
area.
sir.
Yeah. Okay. Okay. Thank you very much.
Okay, thank you.
Thank you, Dheeraj sir. Now I'd like to request Kirti Mishra to kindly share a PPT.
Thank you, sir. Is my screen is visible, sir?
It is getting, yes, ma'am, it is visible now. You can continue.
Very good afternoon to all of you. Myself, Kirti Mishra. Today, my topic representation is graphitic carbon nitride based palladium nanoparticle, a homemade electrode anode catalyst for efficient direct methanol fuel cell application. These are the content. This is introduction, then experiment section, and after that result and discussion, and finally it is the conclusion. So, as we all know that the need of energy increases day by day tremendously. So in today's scenario, we need such a device that produce much energy with low pollution. So much attention pays to the fuel cell devices technology. And that fuel cell commonly based on the catalyst. So initially we use the platinum based catalyst, but we know that platinum is the very costly metal and it has some catalyst poisoning effect. To overcome this situation, we use palladium electrode catalyst for the different material due to its low cost and availability of the greater tolerance to the carbon monoxide poisoning with good catalyst activity. The catalytic performance of palladium nanoparticles be increased by using some support material like graphitic carbon nitride, modified reduced graphene oxide, methanol, as well as formic acid electro-oxidation. Three-dimension graphene supported palladium catalyst shows good catalytic activity than commercially used palladium carbon catalyst for the electro-oxidations of in alkaline medium. Palladium on three-dimensional porous arrangement show better catalytic activity and constancy for electro-oxidation of methanol in alkaline medium. Due to graphitic carbon nitrides, the porosity increased the electrochemical active surface area. In recent study, we demonstrate how to synthesize graphitic carbon nitride based palladium nanoparticle as a catalyst on the homemade electrode for efficient direct methanol fuel cell application, in which zinc oxide doped with platinum nanoparticle with graphitic carbon nitrides with improved properties. various characterization technique
Sorry
like
to interrupt you,
cyclo.
ma'am.
Yes, sir.
Ma'am, your slide share is not visible. So I'd just advise you to prefer with the presentation mode itself. Don't go to the slide mode, because the slideshow that you are sharing is not visible to us. We are on the first screen, first page of a PPT.
She might not first ask whether she has changed the slide or not. If she has changed the slide, then it should change also.
Yes, sir.
Okay, sir. I will. So now it is visible.
No, ma'am, your slideshow is not visible. We are currently on the fifth slide. The slideshow is not visible.
Okay, sir. I will reshare.
Ma'am, you can continue with the same. You need not to go for the slideshow. You can continue with this presentation mode itself.
Okay, sir.
Whatever the default PPT mode is there.
Okay. So the synthesized material is characterized by using various characterization technique like TEM, SEM, ADX, XRD patterns, and most important cyclovoltammetry. So all the materials used to synthesis of the catalyst is analytical grade. First of all, how we prepare electrode. So the electrode, to prepare the electrode, a glass tube of 10 millimeter taken by removing the rubber and tip was cut with the sharp instrument and make into the glass tube. After that, 2K copper wire and clean with the sandpaper to remove deposit impurity or substances like the oxide layer. Insert this copper wire into the glass tube and folded it, making a coil according to the diameter of glass tube and fixed with the tube wall by using conducting glue. This surface area used as the active surface of homemade electrode for the deposition of synthesized catalyst. Now prepared catalyst fixed on this area in pellets by using the carbon black as the fixing material. After that, we prepared our electrode materials like graphitic carbon nitride with palladium nanoparticle. For this, we take some material. First of all, we prepared graphitic carbon nitride. Graphitic carbon nitride basically prepared by using the previous use techniques. And in this study, जो graphitic carbon nitride, zinc oxide, platinum nanoparticles, are prepared for the electro-oxidations of methanol fuel cell application. So carbon nitrides were prepared using the techniques and synthesized by using urea as a precursor molecule. In this, urea is calcinated, then mixed with the deionized water for 6 hours by continuous stirring at the room temperature. And for this, we use the stirrer. After this, a stroke of the 10⁻³ molar sodium borohydride was added and allowed to 15 minutes for stirring, resulting in the reductions of the substances. The reacting mixture is now filtered and obtained residue washed with several times with deionized water to get the solid powdered graphitic carbon nitride. This graphitic carbon nitride now incorporated with the zinc oxide and platinum nano. Yes, sir.
Ma'am, we are still on slide 5. So have you changed the slides?
Sir, I'm changing the slide, but I don't know why it is not visible to.
No, I think you are in the slideshow mode. Kindly come out of the slideshow mode. Okay, now we are on the 7th slide. So no need of slideshow. You can continue with the same slides. Okay, ma'am, it is. We are now on the 10th slide.
This is the schematic diagram study of my study. Here we have taken a potassium tetrachloroplatinate, zinc oxide, and sodium borohydride to make the graphitic carbon nitride. This graphitic carbon nitride is incorporated in the platinum nanoparticles, zinc oxide, and these materials is incorporated into the homemade electrode as discussed. And this electrode material is characterized by using various microscopic technique, and electrochemical study is done by during this fuel cell applications. This is the TEM image of the graphitic carbon nitrides, and graphitic carbon nitride incorporated palladium nanoparticles and zinc oxide. Here this is the TEM image of only graphitic carbon nitride, and this is the TEM image of the platinum nanoparticle decorated zinc oxide graphitic carbon nitride. This is the XRD pattern. XRD pattern basically used to know the crystallinity of the substance. So when we use X-ray diffraction pattern to analyze the intense peak at around 37 degrees Celsius, confirm the formation of platinum nano particles and graphitic carbon nitride based particles. Under this is the FTIR spectra of the, so these are the red curve show the platinum nanoparticle decorated graphitic carbon nitride, and this black curve show the platinum nanoparticle with graphitic carbon nitride. So condensed heterocyclic aromatic rings have carbon and nitrogen shows by this red curve. These are the electrochemical studies, and first is the electrochemical impedance spectroscopy. These curves A, B, C, D are the different. The curve A is the bare graphitic carbon nitride electrode, B is the zinc oxide with graphitic carbon nitride electrode, and C curve is the platinum nanoparticle with graphitic carbon nitride, and D curve is the platinum nanoparticles with zinc oxide and graphitic carbon nitride. So these curves show that as the doping occur, the charge transfer resistance is decreases and the current is increases in fuel cells. These are the cyclovoltammetry diagram of the curves. This black curve show the bare graphitic carbon nitride, and this red curve show the graphitic carbon nitride in the methanol oxide. Basically, this cyclovoltammetry diagram containing two peaks. One is the oxidation curve, other is the reduction curve. So increase in the oxidation curve shows that with the presence of methanol, the current density of the cell increases. And this black B diagram is zinc oxide, graphitic carbon nitride, and methanol shows that with the decorations of the zinc oxide in methanol, the current density value in the anode electrode is increases. These are the.
Please conclude another 1 minute. Your time is over.
Okay. This is the second curve with the platinum nanoparticle with graphitic carbon nitride is methanol oxidation, and these are the three deposit material platinum nanoparticles, zinc oxide with graphitic carbon nitrides. This is the chronoemperimetric profiles of the 0.5 molar potassium hydroxide oxidation with methanol in different electrodes that we are prepared. So our conclusion is the synthesized electrode material used for the fuel cell application showing outstanding performance. The results show that the introduction of zinc oxide and platinum nanoparticle in graphitic carbon nitride positively impact the electrooxidation of methanol by increasing the surface area of the support material. So we need to optimize the techniques for industrial and transportation purpose by which we make it cost effective. These are the references which we use. Thank you.
Thank you, Kirtina, for the presentation. Challenge, sir. Okay, any participants who have any question, they can ask.
Madam, why
Yes,
we use nanoparticles?
Sir, we use nanoparticle to increase the surface area for the catalyst action.
No, ma'am, please read. It is not the reason.
So basically, I work in the composite material.
No,
so when we introduce the platinum nanoparticles,
you have introduced or used a particular type of nanoparticles, right?
Yes, sir.
So you have used particular type of nanoparticles in your study. So my simple question is, why we use nanoparticles?
So because nanoparticles has the porous and it has the greater surface area.
Ma'am, you are introducing this one in a liquid, na? So where is question of surface area?
Sir, I'm not introducing in a liquid, sir. I'm introducing on a solid surface.
Right. In form of particle.
Yes, sir. And my particles is in the solid form, not in the liquid form, sir. Sir, I synthesize the particular material and that material is deposited on the electrode surface. And this material used as a oxidizing agent.
If your question answer is like that, then I should ask, what will happen to the falling when you are increasing the surface, then there will be falling also on the surface. What have you considered falling?
Sorry, sir.
When you are increasing the surface area, just you are told that I am putting on the electrode to increase the surface area. So wherever it means, are you working in the pure liquid?
Sir, I'm not
What
working
is your
on
working fluid? What is your working fluid?
Sir, my work is the catalysis. We just prepare a catalyst to electro-oxidations of alcohol, whether it is a methanol or ethanol. Methanol, like ethanol, sir, we use.
No, madam, I'm not going in that detail. I asked you first question why we use nanoparticles. Then you told me that I'm going to increase the surface area. Right?
No, sir. Sir, nanoparticle has the greater surface area, but purpose is the use nanoparticle to increase the catalytic activity.
Okay, chalo, no issues. Okay, go ahead.
Thank you, ma'am. Now I would like to call upon Swarnil Biswas, sir, for his presentation.
1 minute, I'm sharing my screen.
Yes, sir.
Yeah, is my screen visible?
Yes, it is visible, sir. Kindly maximize it. You can start the slideshow.
Yeah. Hello, my name is Shivran Biswas. So today I am going to present a PPT based on my paper, The Outcomes of Different Dielectric Fluids in the Electrical Discharge Machining Process. So in this, first of all, I will explain you about what is EDM and why I have done this research for EDM and what are the different types of EDM machining and what are the effects of dielectric fluids in the EDM machining process. And at last, I will conclude with my research. So first of all, electrical discharge machining, it is a non-conventional process in which a part is machined with the help of electrical discharge, with the help of electrodes like copper and graphite in presence of different dielectric fluids. So my main topic is dielectric fluids. So different dielectric fluids have different effects on the machine parts. That is why when choosing a dielectric fluid, we have to be very cautious. The EDM process was mainly used in for machining hard materials, but in today's generation, it is also used for or different other parts also. So mainly dielectric fluids like pure kerosene was used generally, but nowadays because it causes great pollution as well as it is very inefficient in the machining process, new substitutes are required. So there are different types of EDM processes, EDM machining, like sinking EDM, micro EDM, and wire EDM. So in the sinking EDM, both the workpiece and the tool are submerged in a insulating fluid such as oil, so that we can and remain so that the machining process can remain its constant heat temperature. So in microEDM is just like the common EDM processes, but the thing is that it can also machine complicated micro cavities and three-dimensional processes also. That is why a lot of research has been made on it, and it is also subcategorized. So coming to wire EDM, it is used as a microprocessor with the help of a wire. So in the wire EDM, 1 minute, is my screen visible? Hello?
Yeah, it is visible. Yes, sir, it is.
It is visible now?
Yes, it is visible. You can continue.
Yeah. So dielectric fluids. So what are dielectric fluids? Dielectric fluids are non-conductive liquids that have very high resistance even at high voltages. So what it does, it absorbs the heat during the machining processes, or it also act as an insulator in the machining processes to contain to control the machining processes and to reduce cause of any accident. So there are different dielectric fluids. So the main traditional dielectric fluids were hydrocarbon and biodiesel dielectric oils. So it was mainly used in the sinking EDM, like the kerosene and oil, but because it is causing a lot of pollution as well as it is causing a carbon addition to the workpiece. That's why the efficiency and the material removal rate of the EDM processes is degrading. So we require a substitute of it. For this, we made a study and we found that there are many other substitutes for it. For example, the gaseous dielectric fluids, O2 and air are two main popular dielectric fluids which are can be considered as gaseous dielectric fluids. But the problem is that the material removal rate and the efficiency of the gaseous dielectric fluids are very low. For this, we can add substitutes in it like the glycerine, and we can also minimize the pollution. So coming to my last point, with the study, you can see the table in which there are different dielectrics and their thermal conductivity, the specific heat and viscosity. For this is the table is shown to differentiate the different prospects of the different dielectrics, and you can see the kerosene part, the thermal conductivity and the specific heat. So coming to at last, water and water-based dielectric fluids. So the water and water-based dielectric fluids are the most important dielectrics which can be used as a substitute for kerosene, because it not only it is environment friendly, but its efficiency rate when I added with glycine and the other non-competitive parts, glycine, it can enhance the efficiency rate of the EDM process, and it can also act as a substitute for kerosene. So coming to my conclusion, under some exceptional machining settings, the material removal rate of gaseous dielectrics and oxygen can also be achieved, and machining in deionized water or distilled water produces a great material removal rate, and the hydrocarbon oils can be replaced by the water dielectric fluids because it is environment friendly, and the material removal rate and efficiency of the EDM process can also be enhanced, and copper is employed as an electrode material in the EDM process because of its excellent electrical and thermal conductivity. Yeah.
Sir, thank you for your presentation.
Thank you.
Mr. Kunal.
Any questions?
Mr. Kunal.
Yes.
Can you give me any example where these are being used?
Pardon, sir?
Can you give some example where these nanofluid, I mean these dielectric constants are used?
Sir, the presenter was Shuvernil. Shuvernil Biswas was the presenter.
Sorry. Okay,
yes,
Shuvernil.
Yes,
Mr. Biswas.
Yes, sir.
Can you give me some example where the recommended dielectric fluids which you are being used? You have recommended something, no?
Yeah, sir. So in the die molding, in the sinking industry, die sinking industry.
No, so example, any example I'm telling. Industry is very long, na? I simply
Yes, sir.
see someone just tells the automobile industry, then automobile industry where?
Sir, in the automobile industry,
No, see, any particular industry is very broad area. So many applications are there, so many softwares are there, so many processes are being there. So which process, where it will be used?
so,
Give me an example.
in making of the chassis, there are different furnished parts which was first which first kerosene was used, but people got to know that the perfection is not that much as compared to the dielectric like water based. So in automobile industry and yeah. At this point of time, only automobile industry is using it. But I think
See, you try to find some actual experiment, practical application, and then your work will get work.
Yes,
now,
sir.
Second question, why? What change in phenomena will take place when we introduce dielectric fluid?
So what?
You are using dielectric fluids.
Yes, sir.
So my simple question is, wherever I will use dielectric fluids, what will happen to the system? Why performance will increase? What happens to the system?
So we are using dielectric fluids because in a system, it absorbs the amount of heat. Because in the EDM process, when the heat is generated, there should be something to control the heat. Otherwise, there are chances of causing accident.
One second, no, please do not deviate. Simple question is, when I am introducing dielectric fluids in the system, what type of change takes place in the system?
Yeah, sir. So thus, the temperature of the EDM process remains constant, and the machining.
Okay, fundamentals are more important than writing a paper. Okay.
Yes, sir.
Okay.
Okay.
That's all from my side.
Okay.
Thank you, sir. Thank you, Vishwas, sir. Now I'd like to ask our IT host to kindly promote Anita Kumari to co-host so that she can present.
I think she has got rights, sir. Sharing rights.
Okay, thank you, sir. Anita Kumari, ma'am.
Yes, sir. I'm audible, sir.
Yes, you are audible. Kindly share your PPT.
Okay. Is it visible, sir?
Yes, ma'am, it is visible.
Okay, sir. Thank you, sir. Start, sir.
Yes, you can start.
Good afternoon, sir. I am Anita Kumari. I am going to present my paper having entitled Selection of Non-Conventional Machining Process Using Critic Kodas Method. My paper includes introduction, objective, proposed methodology, result and discussion, and lastly conclusion. The first I start with the introduction.
Just 1 minute before you. There was a monogram of LJBL on your presentation. So have already it has been presented published?
No, sir.
But there
yes,
was.
Sir, yes, sir. This publisher in this.
So the already sent this paper is already published. Then why? It is not a.
So actually, we have shared this PPT format. It is related to materials today. The Elsevier logo that is used, that is related to materials today, in which we will be giving for further publication.
Okay, no issue.
Okay, sir. Sir, yes, we know that there is a demand of quality, high production, process safety, and minimal manufacturing cost and manufacturing time. In order to fulfill this demand, proper material selection or proper machining process. Proper machining process are required, which ensure the high quality of product, reduce manufacturing cost, and increase the overall productivity. We see that many advanced manufacturing process or material replace the traditional manufacturing process in order to fulfill the demand of growing need. There is a number of alternative options and set of conflicting criteria to make the selection process more complex. A number of MCDM approach are also proposed by the earlier researcher to solve the selection problem, but in some area the individual method does not give the better result. Therefore, a hybrid approach arise to solve this type of problem. The advantage of hybrid approach over the individual method is that it integrates the subjective and objective criteria both into the value of utility functions. Sir, my screen.
Yeah, it is.
Sir, the slide is not
moving. It's not moving.
Yes, sir. Sir, is moving? Sir?
Yeah, yeah.
Okay, sir. Sir, my objective of this study is to solve the NCM process selection using hybrid MCDM method. Having MCDM method which are easy to calculate and give better result, and having less mathematical computation. I have integrate this critic CODAS method which can be easily calculated on Excel sheet. There is no need of a specific software. Sir, lastly, I compare my conclusion to the other outcomes of the other result to validate my results, my conclusions, sir. These are the proposed methodology which I have adopted. Firstly, I determine the objective and identification of appropriate criteria, then formulate a decision matrix. Sir, then generation of normalized decision matrix for critics method, then determine standard deviation and generate correlation coefficient value. Then after this, we determine the weight of the criteria. Then these weight are integrated in CODAS method, and CODAS method is used to rank our alternatives. Then these are the procedure of critic method. Firstly, we formulate the decision matrix. Formulation of decision matrix by utilizing the information and about the available alternatives, and then we normalize the decision matrix. So we normalize the decision matrix to get the dimensionless value. Then we find the standard deviation of that. Then we establish a symmetric matrix that is correlated between our output parameter which we are going to estimate. We have to establish the linear correlation and also have to measure the conflict which is created by this particular criteria. Sir, and this is the procedure of the CODAS method. This method also first we make the decision matrix, then normalize that decision matrix, and then integrate the weight which we find by the critics method. in this method, and then lastly, by using this equation, we rank the alternatives. So, sir, I have taken a material for machining is titanium. Titanium is one of the material which fulfill the demand of need, so that it is mostly used. It is light in weight and corrosion resistance. So this material is now mostly used in aerospace and marine.
Ms. Anita, kindly conclude in another 2 minutes.
Okay, sir. Okay, sir. Sir, these are the alternatives which I select, and these are the criteria which I had taken. Sir, these are the weight which I have found by the critic method, and after utilizing this method, these weights in CODAS method, we got the assessment score, and a higher assessment score is rank as 1, and this is the conclusion, and this is the comparison which I have done and from the earlier researchers in which it is mostly similar to the earlier researcher, and I found that the PAM is the most effective manufacturing process for machining titanium material. Thank you, sir.
Thank you, ma'am.
So, Miss Anita.
Yes, sir.
Why your proposed method is better than other one? You
Sir,
forget about your result. You forget about your result. Whatever you have proposed, why
yes,
it is
sir.
better than other?
Sir, it conclude less mathematical calculation, and it can be done on Excel sheet also, sir. It is no need of knowing software, specialized software.
These are not the correct answer. And further, you have
Yes.
ranked some, right? You have given rank. So,
yes,
given rank, what is the parameter on which you have given marks?
Sir, after calculation, we after
No calculation
after
you have done.
finding the
See,
weight.
no calculation you have done fine. Whatever the calculation you have done, so see, you
Yes,
have
sir.
assigned some marks to some parameter. What is the
Yes, sir.
basis that this parameter will get highest mark? Why?
Highest assessment score is getting the rank 1, sir.
So why? That's why I'm asking why. Why you have given? I mean, see, when we are talking about any process, we should
Yes,
talk
sir.
about whether it is productivity is more, quality is more, reliability is more, something like that. Some parameters are there, na?
Okay, so yes, sir.
So on what are the parameters on the basis of that you have, if the system is, if I will assume process, I will follow this process, reliability of the system will increase. So reliability can be a factor. Safety, if I will use this process, safety will be more. So safety should get more marks than reliability, and then process and something like that. So that's why I'm asking like that. What are the parameters on which you have ranked particular activity? You have assigned marks, now then only rank is there, now 1, 2, 3, 4.
Yes.
So
Yes, sir,
what is the
yes.
criteria of this? Just example I have given that if I am going to use this process, reliability of the system will increase. If I will use this system, safety will increase. So safety should get highest priority, and then like that. So what is in your case? What is valid in your case?
Sir, I select some criteria, sir, on the basis of that.
I want to know the characteristic. I mean the value of the. I want to interested in that parameter only. What is those? What are those parameters? Because see, when you are publishing a paper, they will not ask you the physics or the. But whenever you, I mean, better always it is better to know the process why it is happening like that. If somebody has taken the rank, you have taken the defined that this value should get this much parameter, and you have also followed. So simply do not follow blindly. Okay.
Okay, sir.
Now I'd request Shaq Shabir sir to kindly present their work. Shaq Shabir.
I'm audible, sir.
Yes, you are audible.
Can I share my screen, sir?
Moving IT host, I'd request to kindly convert Shaq Shabir sir to co-host. Yes, sir, your screen is visible.
I'm sorry for the intermission, sir. Power cut is happening and lost power in the laptop, sir. So I'm presenting through my mobile, sir. Sorry for the inconvenience. So good afternoon to everyone, sir. My Sheikh Shabir Ali. I'm presenting my PPT on thermal experimental investigation of the performance of thermal acoustic refrigeration, sir, which is designed by and fabricated by us. And the PPT containing the construction of thermoacoustic refrigerant and results in different control performance and conclusions. Of thermoacoustic refrigerator. The thermoacoustic refrigerator is readily made with the materials we had, and it is fixed with a resonator and the speaker box were made by chemically welding and gluing with PVC pipes and fittings. The stack material was cut to the length and chipped down to the proper diameter, then secured in the resonator. Although it was not roughly designed, a heat exchanger was made and inserted into the resonator at the hot end of the stack. The driver was used to pound, except its flange was slightly modified to fit the bolt holes of the resonator. Finally, the refrigerator was constructed. The completed tar is shown in the figure, sir. In the resonator, coming to the detail resonator and the hot exchanger, the resonator. The portion of the resonator near the speaker was supposed to be 4 inches in diameter. This allowed us to speaker to closely fit the driver end of the resonator. Also, standard PVC flanges could be used where the resonator and driver housing would meet. The hot side exchanger. A heat exchanger for replacement at the hot end of the stack was created from copper mesh and tubing. Several 4-inch diameter circles of the copper mesh were cut from a sheet and soldered to it to increase the surface area and contact of working gas. And then speaker box. To keep functioning gas contained, a speaker box was constructed that could be attached to the resonator. The speaker box, similarly to the stack more portion of the resonator. It is molded to a 4-inch measurement pipe. And the line was managed to length of 15 centimeters, forwarded into a rib period being covered to further stake. The speaker bin in bundles. Screws could be utilized to straight the speaker face, adjust the effects of the speaker box to the resonator. Since faces were grounded to empower fastness to the PVC and instrumentation, sir. As far we adjusted some sensors, use of various control screens required to measure the acceleration and the pressure of the space of the driver side. Other instruments of hot side and cold side temperature within the reservoir. Appropriate sensors as small sensors mounted to the speaker and resonator will take the desired attempt to measure the desired measurements. And the results and discussion. We followed we did 2 experiments arranging with the different temperatures of room temperatures, and as far as we are concerned, a small change will be big in this impact. A pure immense pair will gather for every regulator and afterward convert into more significant amounts, including a state of temperature and contrast. Normal chance to deliver the temperature. Nonetheless, a light of the fact that varies between regulators are miniature. Extra information would be needed to look into that. The extensive, which is provided in figures, the graphs were made as far as we are Those two are the experiments with slightly varying the room temperatures, and even a small change in the tar would deflect those temperatures. So minimum temperatures were occurred while we are doing that. And the control performance. The control performance criteria is convergent, steady state precision, or spread. The convergence time was defined as time it took and on the signal alive. The steady state spread limits to locked on a value. The spread was defined as the maximum exposure of the control signal from its locked on value after temperature differences across the stack, and has featured steady state values used to compare control schemes were arranged over 5 trials for PPL and pressure controls. And the conclusion: a standing wave thermoacoustic bridge was created utilizing Painter's dimensional boundary approach, sir, because of utilizing these problematic parts, for example, the driver and the hot exchanger, and the absence of particular application. The last star was not similar to most of the stars in the writing as far as cooling power proficiency. Nothing less, there was no observable thermoacoustic impact, which took in our consideration to a coloration of the control panels in the using an exchange header model, sir. Since the power control was hard to gather and hard to do, just the acoustic tension control. As far as cooling power and the large productivity, the PPL suppresses the tension incline and climb regulator, while as control rules, the PPL outflanked in the strain slope, rising the large despite the fact reaction and the accuracy might be more basically specially concentrated application. More examination is required under a watchful eye, and discussion is required, and presentation of power control can be made. While starter information recommends this technique for a control to be dependable on any different stages for control investigation in the review. In addition, the most valued of the pack subsequently is the most untempting approach to well, power thickness is more significant on the ground, but is considerably cooling power and less sensors, bridging amount of more rested power. As indicated by the measurement over the train, argument regulator would be center appropriate for gathers of the assembling because of its higher elemental positions. And thank you.
Thank you, sir. Any questions?
Hello, sir. Any questions, sir?
What is the process to change the rule?
Sir? Hello, sir.
I think there is no questions. So we'll move on to the next speaker, Madiha Rahman. So you can share your screen.
Good afternoon, everyone. I am Madhiya Rahman, and I am going to present a presentation on impact of cultivation conditions on microalgae biomass productivity and lipid content, a review. And in this presentation, we will, this are my contents. Introduction. As we all know, the world will need significantly increased energy supply in the future, and we need energy resources that might replace fossil fuel in future. So, as biodiesel produced from microalgae is a great deal of attention. Microalgae are promoted as a third generation biofeedstock. It has several advantages like high growth rate can fix CO2, and in comparison with conventional fossil fuel, microalgae can produce 58,700 liter oil pulp per hectare, which can generate 1,21,104 liter biodiesel per hectare. But the main obstacle is the cost effectiveness, as the production for microalgae can be very costly. So we need to design the photobioreactors in such a way that they are cost effective and the production rate is also high. Also, the lipid release condition needs to be optimized and maintained to achieve higher lipid content from laboratory scale or field grown microalgae. The objective is this paper is to review the salient features and limitations of developed photobioreactors and the impact of different cultivation conditions such as light intensity, light color, temperature, pH, etc. on lipid content and biomass productivity of microalgae for biodiesel production. This paper reveals the optimum range for bioenvironmental conditions for maximum growth and lipid content for various species. It's also give a comprehensive comparison of developed photobioreactors. For the literature review, I've done prepared comparative tables of different photobioreactors, as cultivation can be done in both open culture and closed culture system, and both had its pros and cons. For if we talk about open culture system, that they are more like ponds and lakes, which are obviously less cost effective, less costly, and easy to construct, and large scale is also possible. But the main disadvantage for open culture system is that they have high risk of contamination and poor control over growth and culture parameters like mixing pH, temperature, nutrients, etc. While if we talk about closed culture systems like which include photobioreactor, in which we require less space, good control. We have a good control over cultivation parameters, very low risk of contamination, high productivity. But in this, it's very difficult to scale up production and require large cost to construct and consume more energy. I have compared different photobioreactors with open ponds like a horizontal tubular photobioreactor, flat panel photobioreactor, hybrid type photobioreactor, in which we can see that the low production cost is for open photobioreactors, while the open ponds, while that the flat panel photobioreactors or the hybrid one, and they have high cost. And different other parameters were compared, like process technology, contamination risk, mixing, energy consumption, maintenance, and different environmental factors, productivity. Then after that, I've done the literature reviews on the factor that affects the growth rate of the microalgae, as microalgae lipid accumulation, photosynthesis activity, and growth depend on several factors: light, temperature, pH of medium, supply of CO2, macronutrients such as nitrate, phosphates, potassium, and trace elements like magnesium, cobalt, zinc. And it differs with.
Kindly conclude in another 2 minutes, Ms. Madiha.
Yes, sir. And it differs with the different species. And if we talk about light intensity, different microalgae strains have a different range for the light intensity. As we can say that for Calora species, the experiment was done on the different lux, in which the highest lipid content was found on 2700 lux. Similarly, for the light frequency also, the range for different microalgae species can differ. And I have prepared a table of different microalgae species and compared their range. After that, if we talk about temperature, the growth of different microalgae can take in a temperature range of 20 to 30 degrees Celsius. Similar with pH, it is a very important factor while considering the cultivation of microalgae. And by varying a medium's pH, photosynthesis is affected, which affect the growth rate of microalgae. Same goes for the nutrients. Production of lipid content are greatly affected by their concentration of nutrients, especially phosphorus and nitrogen, and they are very important for the algal development. The findings was that the open culture and closed culture, while they have its own advantage and disadvantage, we need both of the culture system. As open culture system is less costly and easy to maintain, and if we want to grow the microalgae species, which needs the better control on the cultivation parameters, then we should go for closed culture system. And if we we can what we can do that open ponds are cost effective if we hybrid the process of microalgae production and wastewater treatment through
Ms. Madhya, your time is over. Kindly conclude another 1 minute or 30 seconds.
Yes, sir. If we talk about so closed ponds are most efficient at producing microalgae, require less area than open ponds, and it provides a better control. And for the we have obtained the optimum range for different parameters for the light that as I have told that microalgae strain have different optimal light. Typically 400 to 700 nanometer wavelength of light is used for cultivation. Similarly, for temperature 25 to 50 degrees Celsius range can be used for different microalgae strains. And for pH, the optimum range of pH varies between 7.5 to 8.5 microalgae growth, which varies with different strain. And lipid content and biomass productivity can be maximum at different pH. These are the references. Thank you.
Thank you, ma'am. Any questions?
Ms. Madhya,
Yes,
I'd like to know what are the chances of contamination in both this open pond system and closed pond system, and how do you overcome it?
Sir, in open pond system, the contamination risk is very high, as it can be affected by seasonal temperature also, and we can't control the parameters in open pond system. While if we talk about the closed system, we can easily control the temperature, pH, light intensity in that.
Okay, fine.
Thank you, ma'am. Now I would request Sonu. Yes, sir.
Nothing from my side.
Okay, sir. So I would request Sonu Mathur to present.
Is my screen visible, sir?
Yes, sir, it is visible. You can continue.
Myself, Sonu Mathur. I am here to present my presentation on design and development of Mehndi applicator. In this, I will cover up introduction to Mehndi artwork, objective of work, CAD/CAM framework utilized, and conclusion. First of all, about the Mehndi artwork. The people worldwide have adopted the ancient Indian tradition of embellishing their bodies with the beautiful natural artwork known as Mehndi. This art form is popular trend to decorate body parts like hand, foot, bellies, etc. Like real tattoos quickly and temporarily without pain and long-term treatment. The creation of Mehndi on body parts require skilled craftsmanship. Even the most skilled craftsman cannot perform the same workmanship several times due to fatigue and length of Mehndi artwork. Mehndi artwork has its own importance in Indian subcontinent from ancient time. This is very popular on wedding occasion, festival, and ceremonial function in India. The paste is applied on lighter skin of surfaces and absorbed by outer layer of skin in about half an hour. The removal of dried paste of mehndi from the skin leaves a decorative stain on the decorative stain of dark orange color. And in this process, mehndi cones are used to apply the mehndi patterns. Now, objective of this work. The motivation of this work is to position mehndi craftsmanship as an exclusive and sustainable art form. So, an idea of automation of craftsmanship is the primary aim of this research work, and achieved through the integrated CAD/CAM framework, which applies the mehndi as same as created in the workmanship. It is also blend of automation of traditional craft knowledge base, reflecting artistic sense of the class of the artwork. This is framework, CAD/CAM framework utilized for this mehndi applicator. In this, a real sense D435 depth sensor is used to scan the hand. And in next step, 3D reconstruction is performed for the accurate modeling of hand surface. After that, CAD model is supplied to master cam for wrapping of mehndi pattern, mehndi pattern can be in the form of image or vector forms. From that, from master cam we generate a tool path which is utilized to provide motion to the extruder, and lastly printed on the hand surface. First operation is scanning of hand. First of all, structure of applicator. This is pictorial view of applicator. In this, various stepper motors are used for the movement of extruder. Here we use a extruder assembly for the flow of mehndi paste. These are the specification of various electronic and mechanical parts which are utilized in this applicator. First of all, extruder assembly. This is the main part for the flow of mehndi paste through the nozzle. It is connected through a extruder drive, and it runs the nozzle and plunger arrangement and mehndi flow from the nozzle. And here the formula for calculation of flow paste is described in the equation. Delta L for 2 points P1 and P2. And accordingly we calculate the movement of plunger according to diameter of plunger and diameter of nozzle. First, in this first step is scanning of hand. The data from the depth sensor is scanned using the depth sensor D435 using Python program. In the next step, 3D reconstruction of the hand surface is carried out. First point is cropping of the point cloud. Point cloud is cropped to the region required as shown in figure 1. After that, the captured point cloud have noise and outlier data, which is removed through the process of filtration. After that, a surface reconstruction method is applied for the accurate modeling and surface modeling of hand. Next, the mehndi pattern are wrapped to the hand surface. First, the images of mehndi patterns are converted to vector patterns. Then these are set to the surface of hand according to our need. And then after setting the position of vector shapes, we project these.
So you have another 2 minutes to conclude.
The hand surface. Next, in the next step, we generate a tool path for the extruder movement according to the formula discussed in previous slide. This is the tool path shown in the figure. These are the vector patterns, and these are projected to the hand surface, and a part program is generated using mastercam. Next, then we use a printer face for printing the pattern. And this is the view of part program in printer face. Then it is supplied to the to this Mendi applicator, this machine, and and for example, these are these patterns are applied to hand surface. Next conclusion. This Mendi applicator is a concurrent way of working of integrated CAD-CAM approach for the traditional art form of Mendi. The objective of automation of Mendi craftsmanship has been achieved. Sport through CAD-CAM tool capitalize the advantage of automation over traditional work like visualization through virtual CAD, modeling, and automated extruder motion without human intervention. The projection of curve is effective way to generate designs on non-planar surface of hand. In this, the projected points provides the alternative way to generate the tool path. In conventional CAD-CAM systems, there is no, in 3D printing, there is no solution for non-planar surfaces. The projection of, future scope of this work is, it can be improved using some more accurate depth sensor for the surface generation. Any questions, sir?
Thank you, sir. Sir, any question?
Is it portable?
Yes, sir. It is portable.
What is cost? What is the cost?
It is around 1 lakh, sir.
Whether it is cost effective?
Actually, sir, there is no such printer in market. First is the in my work I have tested for feasibility.
No. Do you think, I mean, the person who are working in this area can afford this machine?
Yes, you can utilize this framework for developing new printers.
Can utilize, fine, but are they able to purchase that? The people who are working in this area?
We are going for further studies for the improvements first. Then we can go for.
Okay. Nice.
Okay, sir. That was all, I suppose. So that is the end of this session. And we had completed all the presentations that were there in the session. And we would like to express hearty gratitude to Professor Shailendra Kumar for sparing time with us and giving us a very beautiful and interactive lecture on modeling of heat exchanger, and having a very interactive session chair and asking people and suggesting them few works that they could do in the future. Thank you, sir. Thank you so much for having with us.
Thank you very much. Thank you.
Good. Thank you, sir.
So should I leave?
So now we yes, sir. So we will be leaving for now, and we will join the next session. The participants can join the next session by 2:30. Thank you, everyone. Thank you for participating in ICMMIT. I would request all of you to kindly attend the validity session also. That will be that is scheduled at 5 p.m. Thank you so much.
Practice session in practice session.
Yeah. Presenter Tushar Kanti Bera, he is not yet
Kanti
joined.
Bera is still not joined.
Hmm.
And second is Yesh Kannadhasan, also still he already joined. Second.
Yeah, he has joined. Yeah, then after Ashwasti Amda Chakko, she has also joined, right?
So ma'am, these are the presenters today.
Yeah.
So I request all the participants, those who will present their paper. So these are the just order. In this order, kindly please join. And if there will be no any presenter first, then we can move to the second. And for presentation, we will allow hardly 5 minutes for your presentation, followed by 2 minutes question and discussing session. So all the
Tushar Kanti
participants.
Bera sir has joined already. Okay.
Okay. So I request Dr. Tushar Kanti Bera sir, so kindly please share your presentation, because within a very short period of time we will start, because now automatically 2:28.
Hello.
Yeah.
Hello, sir. Yes, please give me the permission to share my screen.
You can share.
Okay, sir.
You are having the right.
Thank you, sir.
Arvind ji.
सर बताइए सर.
Sir, kindly please check now for Tushar Kanti Bera. Kindly please give him the right to share his screen.
सर सबके पास राइट्स है सर, सब शेयर कर सकते हैं.
Okay, sir. Okay. Yeah, it is okay. Yes, sir. Kindly please make it in slideshow mode.
Okay. Good afternoon, all respected session chairs and dignitaries present in this talk today. So I am Tushar Kanti Bera from NIT Durgapur. I'm here to present my paper on the electrical impedance spectroscopy simulation of the single cell models using NI multisim. So this is the outlines. I will discuss about EIS, then impedance measurement, electrical impedance spectroscopy, EIS for material characterization, that is applications, and then we will discuss about the EIS simulation with multisim software. And also I will discuss a little bit about the MATLAB based EIS data fitting. Then I will conclude my talk. Thank you very much. So motivation is that EIS can be applied for characterizing the materials, and it is a non-restrictive testing. It is very
Tushar
fast.
Kanti sir,
Yes,
once
sir.
I have interrupted you. Tushar Kanti
Yes.
sir, I have interrupted you. Kindly
Yes.
please switch on your video. Okay. Because
Okay.
we need that one also. Okay.
Okay. Just give me 1 minute. I'll do it. Yeah. Can you see me? Yeah. So thank you, sir. So the EIS technique is one non-restrictive technique, and that non-restrictive technique can be utilized for characterizing the materials. It is electrical current or voltage based technique, so it is very fast, it is portable, and it is also found in a standalone device, and it can be taken to the field. So it has many advantages compared to the other techniques, and it is also low cost, that is cost effective. It is found applicable in biomedical technology, food technology, and also in the material characterization technique. So electrical impedance is the material property of any material. There will be certain amount of electrical impedance whenever it will be going under the electrical alternating excitation. So if there is any reactive components like capacitance or inductance, there will be impedance. Otherwise, there will be the resistance, and that will be considered as the equivalent value of the impedance. So for measuring the impedance for any material, we have to apply some electrical signal. We can assume that current is applied and voltage will be developed, or voltage can be applied and current can be measured. So from this voltage current data, if we apply the Ohm's law, we will get the resistance for the DC excitation, and we will get the impedance for the AC excitation. So the procedure is very simple. We will generate one constant amplitude current signal or voltage signal. We will apply to the object with the help of the electrodes. So 2 electrodes will be connected to the object. Another 2 electrodes will be used for the voltage. This method is called the 4-probe technique. And whenever the voltage will be sensed, we can apply the Ohm's law. And if the current is taken as the reference, then there will be no phase angle, and there will be the signal representation with the mathematical representation as shown by this equation, that is Im sin omega t. And whenever there will be any reactive component like capacitance or inductance, there will be phase angle, and that phase angle can be represented by either theta or phi. Now, for 4-probe technique, we need to use 4 electrodes. So there will be 4 contacts, and there will be the contact impedance minimized, or it will be almost negligible. But for 2 electrode technique, there will be contact impedance problem. But in many cases, especially for the biological measurement, whenever the 4 electrode techniques are not possible to be employed, some 2 electrode methods are applied with some modification of the circuit so that the contact impedance can be avoided. Now, for any unknown tissue, if it is applied in case of biomedical field, if we don't have any idea about the tissue anatomy or physiology can be understood by this technique. So if we apply the current signal or voltage signal for a number of frequencies, we can get the tissue response in the field of electrical impedance. So we will call it electrical impedance spectroscopy because the number of frequencies are plenty. That is starting frequency to the ending frequency. There will be several number of frequency either distributed by linearly or logarithmically. So whenever we will have the impedance at different number of frequencies, so we can plot it. We can extract the real part and imaginary part in the x-axis and y-axis respectively, and that plot is called Nyquist plot. And analyzing the Nyquist plot with any curve fitting software, we can get the equivalent circuit parameter for the tissue. And with the electrical model, we can understood what type of disease is there or what type of abnormality is there. If any extra material is formed like tumor or any other cells, then also, that also will be visible in the electrical circuit model. So this is the basic understanding of electrical impedance spectroscopy. This is 2 electrode method where the current injection and voltage measurement will be done with same electrode pairs, and there will be contact impedance as shown by this figure. And if there is 2 separate electrode pairs, like current electrodes will be separated from the voltage electrode, then there will be no contact impedance or minimized contact impedance. So now the procedure is that there will be one instrument which will be responsible for generating current and measuring the voltage. So the detection system and signal generator all will be developed inside or installed inside this instrument. That type of instruments are also available commercially. So there will be 4 electrodes, and that 4 electrodes will be attached to the object under test, and the frequency will be varied from F1 to Fn, and accordingly the Z1 to Zn and theta 1 to theta and all data will be measured. And from those data, that is Z and theta, we can calculate the real part R and imaginary part X, and we can plot those values along the X-axis and Y-axis, and we can get the Nyquist plot as shown by this figure. So now it can be applied in chemical, material, mechanical.
Comes to the 1 minute remaining, please, sir.
Yes, I will complete. So these are the application field: chemical, mechanical, material, civil, biomedical, biotechnology, and food technology, and all. And disease can be also detected. There are many applications and many research work have been conducted for that. And for the food technology also it is done. Now how the impedance is coming due to the cell structure, cell membrane structure, which is nothing but the combination of the protein, lipid, and protein. So proteins are current conducting material, and lipid is insulating material. So definitely there will be some capacitive property in the cell membrane. And from the cell membrane and cell fluids like extracellular fluid or intracellular fluid, there will be impedance. So these are the animations by which we can understand the cell model. And that model is well established. There are several models proposed by either Cole or Frick, and those models can be simulated in the software. So till that point, we have known about the PSPICE or TINA from Texas Instrument, or National Instrument has another software that is called Multisim, and the cell models can be developed, either parallel model or series parallel combinations of the circuit models can be understood. So we have chosen Cole model and the Frick model in Multisim software developed by the National Instrument, and that software can be useful for circuit development, and the biological cell models are studied with the software. After that, we have developed the MATLAB-based curve fitting software so that we can extract the data from the Multisim and can fit it in the MATLAB so that we can get the Cole plot or the Nyquist plot. So we studied for different parameters. We have given some different parameter values, and we have studied the circuits, and those circuits are nothing but the biological cell models. So the conclusion is that EIS is a material characterization technique. EIS is fast, low cost, and portable. EIS can be used for studying different types of materials, and EIS needs a multi-frequency signal generation. So all these things can be simulated in the multisim, and we have studied with the RC blocks and switching, and also we have studied those electrical circuit models for understanding the electrical impedance spectroscopy in multisim. These are the references. I acknowledge ICMMIT organizer and the session chairs and all the organizing committee members and the participants. Thank you very much.
Yeah, thank you, Dr. Tusarkanti sir. There is also one question.
Yeah, please tell.
That is how to, I think you all also saying how to impedance comparison for various electrical parameters.
Okay, so the impedance, whenever we will get the impedance, we will develop the circuit model, and for developing the circuit model we need to analyze those data in the MATLAB, and the MATLAB will give all the circuit parameters, because the MATLAB algorithm will be written in such a way that all the data points will be fitted in a circular path, and from the circular path whatever we have got, we have some theoretical discussion that all the resistance will be from starting from 700. So wherever we can see that here resistance taken is 700, and also this curve is showing that resistance is 0 to 700. So if that value is known, then we can compare it. So we did it with known values earlier, and then if we have some unknown values, after getting the plot also we can get the value of the resistance and the reactance. Reactance will be at the center point somewhere here, and it will be the maximum value or peak value in the y-axis component, that is reactance. You can see that imaginary part and you can see the real part. So, and also if the curve doesn't start from 0, if you start from the away from the 100 ohm resistance or 100 value or anything, that much value will be connected in the series combination with the parallel one.
Thank you, sir. Thank you
Thank you,
for
sir.
your nice presentation.
Thank
and
you, sir.
also
Thank
request to Dr. Jaita ma'am, if you are having any queries, Dr. Jaita ma'am.
Sir, I have one query that how the shape of the that particular EIS curve can be related with the physical characterizations of a material.
Okay, so if for example, if there is any formation of tumor, so there will be lot of metabolism which is not regularly seen in the normal tissue. So the more metabolism or more oxygenation is requirement means more circulation of the blood flow. As the blood is very highly conductive, so automatically that region will have very less resistance, less impedance. So we will see that the curve of any tumor cell height and the width both will be reduced compared to the normal tissue. So comparing those values, there are many standards values are already published. So those comparing those things, we can tell that this value is the malignancy or started kind of, we can do that.
Thank you, sir.
Thank you, sir.
Thank
now
you,
I request. Yes.
Thank you, sir.
Thank you, sir. Thank you. Now I request to S. Kannadasan, sir. Kindly please share your presentation. Tusarkanti sir, kindly please stop sharing.
Yes, yes.
Sir, can you start the
Kindly
process?
please share your. Yes, sir. Yes, sir. You can start.
Yes, sir. Okay. Good afternoon, all present here. This is Kannadasan, working as assistant professor in the department of ECE from Charangal of Engineering, Karur, Tamil Nadu. First, I am doing the research in the field of wireless sensor networks and in the field of and also the combined with the smart antennas. in L-shaped structure using the various series substrate. Also, thank for accepting my paper for international conference on materials, machines, information technology, organized by ICMMIT University, Jharkhand. The vision of this paper: motivation, objective, introduction, literature survey, proposal, summarization, conclusion, reference also. Nowadays, a lot of Microsoft designs to determine the various structures have increased tremendously for various applications also. The mostly drawback for challenges in the drop bandwidth of the most challenges in the Microsoft batch antenna is overcome of the issues of the research work. Therefore, the micro and RF design implement the research of the combined of micro design also. Therefore, the IS design for one structure of L-shaped structure using the ceramic substrate. A lot of substrate available in the Microsoft batch antenna FR4 users. That is a ceramic substrate is a bandwidth constant is a more benefit with a ceramic substrate also. So I will choose in the ceramic substrate. So I just communication is for various applications for communication applications such as broadcasting, remote sensing, and space communications also. Therefore, nowadays you know what a VSAT system in the satellite communication systems of the Microsoft batch antenna. In this all the type of antenna batch in the 3D plan structures in the VSAT structures also. Therefore, in navigation both the broadcasting and navigation mobile satellite using the mesh structure proposal antenna. The main upside of the L-shaped for a rectangular mesh batch antenna, it is flexible, so that means the ceramic substrate. In this ceramic substrate, you use RMC designed for. I have chosen for a frequency resonant frequency from 2.5 GHz to 8.0 GHz with the help of the some more substrates, polyethylene solution, CML 1032 and polyethylene substrate. This is the most of ceramic substrate also. This all the substrate we can design analyze the performance of the serial slot using the gain and also the bandwidth. Also the greater bandwidth mesh structure. The realized concept of dielectric and dielectric magnetic traditional the ceramic substrate higher the micro and millimeter frequency bands. Nowadays, a lot of structures on and in using the micro and millimeter bands also. Some literature surveys in this paper consider for a single monopolar antenna, then satellite television, good result in VSWR. In this area, reference to the Y-shaped structure can use for dual band frequency and also the fabricated structure and the performance of the board is similar and the fabricated also. Therefore, the space comes used in this paper. Another paper E-shape structure, it is used for WiMAX applications. Good result in VSWR gain and radiation button also. In this paper, E-shape structure, but different thicknesses of substrate used in this paper and comparisons of the it is used for wireless communication also. This is my structure, L-shaped structure for different lengths for L1, L2, and L, and a different width of W and W2 and W. Normally, in Microsoft, we calculate the basic formula. Microsoft, we can calculate length and width of the batch antenna. In this antenna, we use it for a 5 more elevation angle. That means of a L-shaped is a elevation angle degree of RDC constant for the single mode constant elevation angle DOT92. In this micro switch of batch antenna, back sector antenna, the antenna length is total of the width is 9.5 and also the width of the 913.33. The L1 is 6.5 and L2 is 3. All the parameters you can calculate in the basic formula of the Microsoft antenna. W1 is a 3.3 and W is a 10 mm also. Now it is used for as GP substitute to use a size and width of the actual and the requirements of the antennas also. Therefore, the L-shaped structure used a ceramic substrate used a low cost substrate and also the flexible used in India microbial structures also. Then this is my reflection question of the L-shaped structure. The maximum value is reached as a marriage.
You are having only 2 minutes time. Kindly please conclude and come to the conclusion part.
Okay, sir. The maximum is 29.72. The minimum is 18.2 in reflection coefficient. And also the VSWR, the maximum is 1.92, 1.72. The minimum is 1.45 obtained in the VSWR. The gain is maximum is 6.78 decibel. The minimum gain is 4.52 decibel. Using as this is the radiation band of the E field and H field of the antenna. The overall discussion of the conclusion of the work is here. The maximum is 18.6, minimum minus 29.72, minimum 18.78. Therefore, gain also 6.78 and 4.2 minimum. That will conclude my work. The LC is a better of a ceramic substrate for using IMS application. It is a good matching from the bandwidth. It is a constant is overcome the research work. Therefore, a feedback is used in the resonant frequency of the multiple frequencies used probably in this synchronization. Thank you, sir. Thank you, 100%. This is my references also. Any queries? Thank you. Thank you. 100%. Thank you.
Thank you, Kanna Hasan. Thank you, Kanna Hasan, sir, for your presentation. And if anyone having any questions, kindly please put it in chat box if any. And on the same time, I also request Dr. Chaitya Chakravarthy ma'am, if ma'am is having any doubt.
Thank you. I don't have any doubt. Nice presentation. Okay.
Thank you. Thank you so much.
Yeah, thank you.
Okay. Thank you, Kannadasan sir, for your presentation. Now I request to Mrs. Aswasti Anda ma'am, kindly please share your presentation. Ma'am, kindly please unmute yourself.
Can you hear me, sir?
Yes, ma'am. You can start your presentation. It is fine. Kindly please make it in slideshow mode.
It's not coming.
Ma'am, you just press F5.
It's not coming, sir. I'll just stop it and once again share it, sir.
Okay, ma'am. Neither you can start, not an issue. You can start also. We are also saying.
Okay. A very good afternoon to everyone. My name is Ashwati Tako. I'm a PhD research scholar of Karnataka University. My guide is Dr. Bajolin Edwin, sir. Here, my topic is intrusion detection using machine learning techniques. And this is my agenda of today. Moving on to the introduction part. We all are living in a digital era, and we know that all of us are using the internet every day, and so many data are being generated every day. And all this data is being stored in a huge big data server. And we know that all these data are being attacked by the hackers every day. And the hackers are becoming more brilliant and more creative than us, and they know how to insert the malware into which place and when to insert the malware, and they know how to bypass the virus scan. And we know that so many big companies like eBay, Adobe, and all, they have some high protective security measures, but still they all are being attacked by the hackers. Why this is happening? Because still, even though we have the traditional security measures, we need to have some high security measures for protecting all this data at the beginning itself. So here we know that a cyber attack is actually, it does not happen in a single stage. It happens to different stages. In the first stage of the cyber attack, what happens is it gains some access to the internet through an email. And once it accesses, what happens is the attackers will start inserting a malware into the organization's network and move on to the next stage. The next stage, what is happening is it is actually moving laterally and starts gaining the information. This stage, which starts gaining the information, is called the lateral movement. So this lateral movement is a very important stage in the cyber attack. And if we have some mechanism for finding the lateral movement trace in the beginning stage itself, it will be benefit for society, for the organization, for the individual, so that it can stop the cyber attack at the early stage itself. So in this paper, in my paper, I'm suggesting a fuzzy neural network technique combined with a machine learning technique. We know that a cyber attack is nothing but it is actually gaining an unauthorized access to a computing network, which means that it's actually causing so many damages to the organization, society, people, and all. Even though we have so many traditional security measures like using a firewall for the internet connection, making the Wi-Fi secure, training the employees in the cyber security principles, regularly changing the passwords and all, we know that still hacking and cyber attacks are being happening. Why this is happening? Because we don't have a much efficient method for stopping the attack at the beginning itself. Here, when I read some papers through my literature survey, I've not mentioned all the papers, but still a few papers have been kept here. So many techniques have been used for finding or for detecting the intrusion detection with so many data sets. But here, my problem, I am saying about the advanced persistent threat. What is advanced persistent threat? It means that attack is happening in an organization and it is not being detected for a long period of time. What happens if it is not detected for a long period of time? All the data might have been lost by the time organization will understand that all the data has been lost. So this should not happen. There should be some mechanism for stopping the cyber attack at the lateral movement stage itself. So I'm proposing a method that is I'm setting. First of all, in all machine learning algorithms, we know that the very first step is actually collecting the data. And we're collecting the data and we're splitting the data into two parts. That is the training part and the testing part. And the training part, actually, we are then normalizing the data, and then we are using the fuzzy neural network, and then it is combined. We are training data using the fuzzy neural network and the deep belief network. The principle of using the fuzzy neural network is nothing but, we know that when we see a building, even if we don't know the measurements of that building, or we don't know how to measure the height of the building, we can understand, seeing the building itself, we can understand whether that building is big or small. The same way, even if data is not precise or if it is uncertain, we can find, it helps us to make decisions using the fuzzy neural network. So in the similar way, here data is being trained using the fuzzy neural network and the deep belief network. And the same technique or the same method is being applied to the testing data. After finally, what happens? We are actually comparing to find the difference between the predicted one and the normal one. This is actually the architecture of the fuzzy neural network. And this is a diagram which shows the comparison of the different machine learning algorithms with the proposed one. And in the figure, it is shown that the first few are the machine learning algorithms, and the final one is my proposed one, that is the fuzzy neural network. And it gives more accuracy when when the fuzzy neural network is combined with the machine learning techniques. It gives more accuracy for predicting the lateral movement traces, which helps the organization to understand the lateral movement traces. Thank you. And I thank the ICMMIT University to give me an opportunity to participate in this conference. Thank you.
Thank you, ma'am, for your nice presentation. Now I request to Dr. Jaita Chattopadhyay, ma'am, if ma'am is having any doubt.
I don't have any doubt. Thank you, ma'am. Thank you for your very much informative presentation, but I don't have any doubt.
Thank you, ma'am. Thank you, sir.
Yeah, thank you, ma'am. 1 second. So now I request, kindly please, ma'am, stop your sharing. Now I request to Usman Ali Hasmi, kindly please start your presentation.
Hello, yes sir, can you hear me?
Yeah, I am hearing. You just start your presentation by sharing your PPT.
Sure, sir. So good afternoon, everyone. The topic of my paper is effects of using polyethylene terephthalate in food packaging industries on habitat and its possible and alternatives. So it's a review paper. These are the contents. So let's start with the material that changed the food packaging industry, polyethylene terephthalate. Founded in 1953, polyethylene terephthalate brought a revolution in food packaging industry, especially in beverages sector. The reason for the widespread use of polyethylene terephthalate is the food preservance quality of the material. The properties of polyethylene terephthalate includes good chemical resistance, dimensional stability, and lightweight. So the question arises, why polyethylene terephthalate is used so extensively? So the reason is the chemical and mechanical properties of PET make it the preferable choice in food packaging industry. PET is readily available and relatively inexpensive. PET has high strength to weight ratio. PET is very resistant to moisture. This is what makes the PET the preferable choice for food packaging industry. So the question arises, why extensive use of polyethylene terephthalate should be a concern for the whole world? PET is ubiquitous. PET waste is found absolutely everywhere from the Arctic to Antarctica. It clogs street drains in our cities. It litters empty grounds to national parks and is even piling up on mountains. PET waste is found in the abdomen of more than 90% of the world's seabirds, in the stomachs of more than half of the world's sea turtles, and it's even choking the life out of whales. At the rate at which PET with plastic is accumulating in the oceans of the planet, it's predicted that by 2050, the mass of plastic in the world's ocean will exceed the mass of all the fish that live there. And that's what the reason PET is becoming the main source of wildlife killing. So let us look at the materials that can possibly replace PET in soft drink industries in the coming years. So the first one is BioPET. BioPET has been around for some years now. It is a plastic based on 30% renewable raw material and 70% oil-based raw material. The mechanical and thermal properties of BioPET are similar to other oil-based PET products. However, the color tone may slightly differ depending on the type. BioPET is still not reliable and it's not the answer to replace PET. So let's move on to the second possible alternative. So here are PEF and PTF. Both polyethylene furanoate and polytrimethylene furacarboxylate, which are PEF and PTF, can be delivered utilizing 99% of inexhaustible sources. They are recyclable and outwardly like standard PET, yet with obviously better mechanical and gas boundary execution. PEF creation ought to be incorporated into existing PET polymerization lines, while PTF is now a stride ahead in the way towards modern creation. Those materials are not yet available and the status of their industrialization is uncertain. Also, they are unlikely to be recyclable with standard PET streams, which can be a major barrier to reception. Finally, there are some concerns among mainstream researchers identified by the shift of certain mixes from thematic dividers to food. So there's a lot of research has to be done before commercializing PEF and PTF. So the third one is PLA and PHA. The well-known ecological polymer at present utilized in beverages packaging industry are PLA, a thermoplastic polyester got from sustainable acids, for example, starch, custard, or sweet stick. It might give the idea that PLA could be the answer for every one of the ecological difficulties identified with plastic business sectors. However, that is false. Truth be told, PLA is ecological just in explicit temperatures and mugginess conditions. That is, you cannot throw a jug into the sea or leave it in the forest to break it. In endogenous habitat, it takes years to fully biodegrade.
Kindly please come to the conclusion part. You are having 1
Sure,
minute
sir.
more.
Sure, sir. So my conclusion is PET can be replaced in the coming years by these given materials, but there's a lot to be done to make commercialization of these materials. Thank you, sir.
Okay, Usman.
Yes, sir.
How many review paper you have surveyed for that? How many research paper you have gone through for this particular research paper or anything?
Sir, me and my guide, Mr. Kapil Rajput, have gone through around 30 to 33 papers.
Okay. So you are finding that PET is not that much, so that's why you are given for PLA can be replaced.
Yes, sir. PET should be
So it
replaced.
is safe.
Yes, sir.
It is safe. It is safe for human food.
No, sir. The PET is not safe for human, and it is not safe for the environment. That's why it has to be replaced. And these
I am asking, PLA is safe now.
Yes, sir. PLA is much safer, but the commercialization is still not much possible.
So, so that's why you are going for BioPET.
No, sir. The perfect replacement would be PEF and PLA. BioPET is made of 30% of renewable resources and 70% of oil-based.
Okay. Thank you, Usman. And Jaita ma'am, are you having any doubt, any question to Usman? Okay, ma'am. So Usman, kindly please, thank you, Usman, for your nice presentation.
Thank you
So
so much.
just stop the sharing. And I request to Mr. Abdul Jabbar Ansari, kindly please start your presentation.
Yes, sir. Am I audible, sir?
Yes, sir, you are audible. Kindly please share your screen.
Yes, sir. Can I start?
Yes, sir, you can start. If possible, you can make it in slideshow mode. In the above, you can find slideshow. Either you can press F5.
No, I can easily present from this slide. Okay.
Okay, go on.
Okay. Good afternoon, sir. Myself, Abdul Jabbar Ansari, and I'm a research scholar in Imperial University. My guide is Dr. Mohammad Anas, sir. My topic is microstructural characteristics and mechanical behavior of reinforced aluminum-based surface composite synthesized by friction stir processing route. Basically, it is a review paper which will summarize the FSP work on the aluminum. Moving on, list of contents, introduction, fabrication of aluminum metal composite, friction stir processing, parameters of friction stir processing, conclusion. As we know that it is a common knowledge that the aluminum alloys are the material of choice for different properties like lower wet density, high strength to weight ratio, and high corrosion resistance. And however, being a soft material, the poor resistance restrict the application of these alloys in contact surfaces. So currently these days, researchers has more focus on composite material to enhance these properties of aluminium. Now, fabrication of aluminum metal matrix composite. As we know that though by conventional method like stir casting, composite casting, powder metallurgy are well-known process for fabrication of aluminum metal matrix composite. But agglomeration, non-uniform distribution, interfacial reaction, porosity, leading to poor matrix particle bonding are common defects associated with liquid metallurgical process. And if you know that, if you see that the previously some thermal spraying methods and laser beam techniques also developed for fabrication of AMMC. But high operating temperature associated with these techniques, so it is very difficult to avoid intermetallic reactions between matrix and reinforcement material for the formation of undesired phases. So for removing these things, we will use friction stir processing technique. Basically, FSP is a solid state joining process. FSP is a solid state fabrication process, and FSW, friction stir welding, is a solid state joining process. In FSP, the process involves clamping the workpiece together on the machine bed. We can see in next slide in figure, the process involves clamping the workpiece together on the machine bed along the putting face of the joint, and a non-consumable rotating tool with a specially designed pin and shoulder is plunged between the faces of the joint and traverse along the joint line. The heat available between due to the friction available between the workpiece and tool, localized heating in vicinity of the immersed rotating pin, causing the plastic deformation of the material. In addition, the generated heat softens the material and creates a plasticized region around the plunge rotating pin, while the shoulder of the tool prevents the eagerness of the plasticized material from the weld. Now, these are the processing parameters of the friction stir welding, friction stir processing, and by altering these. Yes.
Sorry
Yes.
to interrupt you. Actually, your slides are not moving.
Yes. Is my slide visible?
We can only see the first slide. That is
Oh.
titled presentation slide.
Okay, ma'am.
Yeah, now it is okay.
Okay. Now, these are the processing parameters of friction resistor processing, and researchers have found that by altering these parameters, we can also alter the mechanical properties, microstructure, wear properties of the base material. These variables like machine variables, axial force we can change, tool rotational speed we can also alter, tool travel speed, tool tilt angle. We can also alter the tool variables like tool shoulder diameter and tool profile, pin diameter, and we can also change the reinforcement materials like some researchers have reinforced silicon carbide, titanium carbide, boron carbide, and we can also alter the base material properties by changing the number of passes. Now, this is the table shows the researcher work. A researcher work selected the aluminum powder and the reinforcement reinforcement material like silicon powder. He selected a diameter of tool shoulder 16 millimeter and tool pin 6 millimeter and height of tool pinch 1.2 millimeter, and found that the result that the more refined grain structure is obtained and strength of the composite also is increased. More like these result also obtained by some other researchers, like some found that when we reinforce titanium carbide particles below 60 micrometer size by increasing the tool rotational speed, the some properties have also increased. So these are the tables which shows the different researcher work. Moving on the conclusion part, it is observed that the grain structure of the almost all the aluminum materials matrix is refined by friction resistor processing route, and it is also found that the hardness of the material base material is increased by increasing the volume fraction. Volume fraction is the percentage of the reinforcement particles, and we can also alter the mechanical properties and different properties of the base material by increasing the number of passes. But there is some disadvantages of multi-pass because the amount of heat generated increase drastically, which produce negative effect on the properties of the fabricated material. Because I also in previously I says that by increasing the amount of heat, intermetallic reaction is started. So it has found that they concluded by the varying the process parameter of FSP, the mechanical properties of the composite can be altered. Thank you, sir.
Yeah, thank you, Abdul, for your presentation. And Gaita ma'am, are you having any doubt, any question? Okay, thank you, Abdul, for your presentation. And now moving towards Dr. Tusarkanti Bera, sir. Kindly please share your presentation, Tusar sir, again.
Hello, sir.
Yeah, sir.
Yes.
Sir, just increase the size.
Is it okay now, sir?
Sir, yeah, now it is okay, sir.
Okay, sir. Okay, good afternoon all. So today we will discuss about the electroencephalography, that is EEG, and the Alzheimer's disease. A short review is conducted on that. So we will discuss about the disease and also discuss about the EEG, that is electroencephalography. So in the talk, we will discuss about the human brain and Alzheimer's disease, and how Alzheimer's disease is used, is caused, or how it can be cured, or whether it is possible to be cured or not. The detection, then what is the role of the EEG, and how EEG can help for Alzheimer's disease detection. So human body is a very complex biological system, and we know that there are several cells and tissues with which the human body is developed, and there are all the living organs are working 24 hours to keep our body healthy and alive. So in that biological system, the brain is the central processing unit or the main organ which you will control, which controls all the other organs so that the body will be alive and healthy. So the nervous system is a system which transfer the signals generated in the brain for controlling or giving the information for being controlled. And also it receives the other signals which is generated or available at the sensory part or the body extremities. So brain is developed with a complex system and there are several lobes and several parts, and each part are responsible for conducting several works like speech, thinking, algorithm development, seeing, that is visualization, hearing. So all these things are controlled by the brain signals which is generated in the brain. Brain tissues or brain cells, that is called neurons. So neurons are the biological cells which will be conducting or working as the electrochemical signal conductor, just like the electrical conductor, whatever is found in our engineering. So the brain cells are the neurons having the parts, that is axon and dendron. On there will be the junctions of two cells, and there will be the electrochemical conduction or electrochemical say junctions. Those are called synapse. And whenever these brain cells are affected due to some reason, physiological problem, there will be some discontinuities of the signal conduction, and automatically we will be losing some signal or information. So brain will either fail to generate the required signal, or it will be, if it will be failing or feeling difficulty in receiving the signal. So those type of problems will become, and there's the system, that is the central nervous system or the peripheral or peripheral nervous system, all will be suffering from the abnormal function of the body. So how the Alzheimer's disease are created? Alzheimer's disease is a complex and multifunctional, slowly progressive neurodegenerative disorder. Neurodegenerative disorder means which will be generated in the neurons and which will not work in a particular order. So there will be several ventricles will be created more than the requirement, and there will be the cells which will be dying gradually, and it is very difficult to stop that disease. And that disease is very common in Western countries. Even in the India also the type of diseases are there, and that is very dangerous, because whenever the brain cells will die, we will not be able to keep the things in our memory. It may also happen that one person will go out from the house and he or she will forget to return. So that type of things happens for the Alzheimer's disease patients. It is very, very dangerous. And for detecting, there are several techniques, but EEG is one kind of technique which is very effective for giving the information about the brain functions. We will discuss about that. So there are several types of Alzheimer's disease, that is mild or severe Alzheimer's disease. Severe Alzheimer's disease means whenever it is progressed a lot and there will be a lot of cell destruction. And if it is not detected, then it will be sometimes it will be life-threatening, because if somebody cannot act as per the atmosphere or as per the environment, they also will fail to take the decision, and also there may be some road accident, and that type of things are also found for the Alzheimer's disease patients. So actually, whenever the Alzheimer's disease patients say cells are studied, we have seen that the normal the healthy neuron structure is destroyed, and there will be several amyloid plaque which will be not able to accept the signal, or which will not be able to conduct the proper signal. So there will be problems, and these plaques are animated here. We can see that all will be affecting all the extremities of the brain cells, and Alzheimer's symptoms will be so there will be several communication problems. These are listed, that what type of social problem or physiological problem or medical problem may occur. Main is the memory loss, and also sometimes if the people are not able to identify their near and dear, so there will be huge communication problem, and there will be also social problem also. So some diets can be maintained, but that is not the curing, or that is not the medicine. And this kind of things are generally found for the elderly patients. And we will go to the EEG due to the lack of time. So EEG is a brain signal acquisition technique. It is called electroencephalograms. So encephalogram is nothing but putting the electrode or sensors which will acquire the brain electrical signal which are available on the surface of the scalp. Sometimes EEG also are conducted subdural in nature, and subdural nature means we will be putting the electrodes inside the brain, that is below the dura. So it will be touching on that. During the surgery it is done, and sometimes it is conducted whenever some major operation is to be conducted or major operation is to be done for any patient for the curing of any neural disorder or disease. So in brain trauma also, or brain injury also due to the accidents, there are sometimes internal EEG or internal electrodes are placed. So EEG signals are several types, and those signals can be acquired by the electrode positioning, which is generally having some 10-20 standards position. And those electronics which are useful for amplifying the signals, that type of normal electronics circuits are required to be employed for acquiring the small signals. Signals are coming generally in the microvolt range. So this type of several microvolts range signals are not properly measurable with the normal measuring device. So we have to apply the amplifier. So amplifier will amplify the signals, and there will be several amplifiers either parallelly working, or there will be switching techniques. Sometimes if the number of amplifiers are less, then we can switch the electrodes. But in general, there will be several number of amplifiers working parallelly for each pair of electrodes. And like that, we will be having some costlier instrument for higher number of electrodes. So if that number of channels for the EEG amplifier is there, so automatically the cost of the instrument will be
Please come to the conclusion part, please, sir.
Okay, so many instruments are available which can acquire the EEG, and that EEG is useful for giving the signals. But EEG signals are very complex, and for human being it is very difficult to understand. So that's why the signals which are acquired from the EEG, that is processed by the artificial intelligence technique like machine learning or deep learning, which will be employing some computational algorithms, and they will be trained by some known data, and that data sets will be collected from the several patients, and doctor already identified those patients will have that stage of Alzheimer's diseases. And after getting the training, automatically the algorithm will be able to identify for the unknown data, which will be the raw data. So we can give the data to the computer, and the computer will extract the data information from the EEG signal, and with the help of computation we can get the data. So we have studied several papers for that classification of Alzheimer's disease from the EEG signal using robust PCF feature extraction, and also the electroencephalogram based biomarker detection for the Alzheimer's disease. So those type of works are going on, and we are working on that. So human brain is the CPU of our body. Alzheimer's disease is a non-curable disease. Alzheimer's disease detection is very important to fight against it. EEG-based Alzheimer's disease detection is a promising approach. Using AI technique, we can extract that disease information from the EEG waveforms and collect it from the patients. And a number of opportunities are there for making the system in wireless, so that we can help the patients which are staying in the remote portion, because the AI-based techniques needs a huge computational techniques, that computational techniques or computational infrastructure cannot be taken to the patient side. So definitely data should be available in a computational room, and that data will be processed by the AI algorithm, which may need some time. So automatically we need some data transfer technique which can be conducted by IoT, and we can get the data from the remote side or the patients which are staying in the remote area. So this is our acknowledgement. I'm thankful to MIT University for giving me the platform. Thank you.
Yeah, thank you, sir. So I am having one simple question. Is it genetic disease, Alzheimer's?
Yes, definitely. There are classifications, and I have already shown that. So this is also the genetic genes are there. That's why the DNA detection is very, very important for that.
Okay. And Jaita ma'am, having any doubt, Jaita ma'am?
Thank you, sir.
Thank you, ma'am.
Thank you, Tushar sir, for your presentation. And please stop the sharing so that we can move to next presenter, Mr. Abhishek Patwal.
Thank you, sir.
So, Mr. Abhishek, kindly please share your screen and start the presentation.
Good afternoon, sir. Am I audible?
Yeah, you are audible. Kindly
Yes,
please switch on your video and share your presentation.
Yes, sir. Just a second. Is my screen visible, sir?
Yeah, your screen is visible, and yeah, okay.
Yeah, so I have been carrying a comparative study on performance parameter of diesel engine, in which there are different blends of biodiesel, including the linseed oil and the karanja oil, at different percentage from 10 to 40% with pure diesel. So the experiment has been carried out, and in which in the presentation I would be like to tell about the introduction. I will tell the experimental setup, the procedure which is followed. After that, the result and discussion, in which the 4 different parameters, including indicated power, brake thermal efficiency, brake specific fuel consumption, and mechanical efficiency, are compared with the diesel engine. And at last, the conclusion will be there. So first of all, I would like to give a brief introduction. As we all know that there is a very increasing demand of fossil fuels and there is a crisis nowadays. So we are moving towards a pollution-free and renewable fuels so that it could be very beneficial for us. So in this study, the linseed and karanja use at different percentage from 10 to 40 with pure diesel. So there are 8 different fuels starting from L10, L20, L30, L40. This L10 to L40 are the different percentage in which there is a share of linseed and diesel. If we and the other 4 fuels are karanja fuel. So this was a very small introduction about the topic. Now there was an experiment set up in which the procedure was followed. First of all, there was an engine there was a diesel engine 4-stroke whose compression ratio was 18 and the rated power was 3.5 kilowatt. In the constant speed of 1500 rpm, the experiment was carried out. So we used the software engine soft LV in this one, and the engine was connected to the computer so that the data of different parameters could be carried out and could be carried at a place. We took the readings and we stored in the hard disk of this. Different loads were given from 0 to 100% in the different interval of 25%, 0, 25, 50, 75, and 100, in which our initial load was 0 and the top load was 100, and the reading was taken in this form. So the procedure, first we made the blend of linseed and karanja from at different share, and we make a biodiesel with diesel and linseed, and the another one was linseed, karanja and diesel. So for making the engine work stable, first around half an hour to 45 minutes, it was started and it was kept at a constant speed so that it could be stable and would give the better values. So there were different sensors like piezometers, gyrometers, which were also used in this. And the very important thing was the engine soft LV, in which from 0 to 100 engine load, we got the values. So when we did this experiment, we got different values, and in which we have compared indicated power, in which we got that linseed shows the greatest indicated power of 5.18 kilowatt at 100% engine load. So it was concluded that time that it could be a better replacement of diesel if we use this one. And as it is a vegetable oil, it would be less pollution. It would create net pollution in compared to pure diesel. Then brake thermal efficiency from 0 to 100%, we got that we got to know that at top load condition of 100%, the 31.99% of brake thermal efficiency was carried out. And if we talk about brake specific fuel consumption, it should be less among all other cases. So at 25 to top load condition, exclusion we excluded the 0%. From 25 to 100, we got the similar values if we compare the pure diesel and linseed biodiesel. And karanja got the highest value, so it was not beneficial for us. And if we talk about the mechanical efficiency, we saw that the 4 shares of linseed that were L10, L20, L30, L40 with diesel were giving the highest mechanical efficiency of 75.6% at top engine load of 100%. So at last, we concluded that this experiment was analyzed and the various performance parameters, which were 4 different parameters of diesel engine when they were fueled with different biodiesels of linseed and karanja. So based on the experiment, we got the result, and we were concluded that it could be the linseed biodiesel could be a proper replacement for the diesel engine. So this was all, sir. Thank you.
Thank you, Abhishek, for your presentation.
Yes.
And now I request to Jaita ma'am, if you are having any doubt. Okay, Abhishek.
I think researchers are working on biodiesel for at least for last 15 to 20 years, right?
Yes, ma'am.
But biodiesel is still not that much commercialized,
Yes, ma'am.
right? What is the actual limitation? Why it is not replacing the actual oil?
Ma'am, actually, when we were comparing the result, yes, of course, we got the better result than diesel when we compared the linseed one, but somewhere we got the similar values when we compare the brake specific fuel consumption. If we compare the engine efficiency, the very first thing which come in our mind is, sir, the brake specific fuel consumption. We got the similar values. So, sir, this could be one reason, as I have my 8th semester and I can go for the further research for I am doing this, sir.
Okay. Thank you. Thank you, Abhishek.
Thank you, ma'am. Thank you, sir.
Okay. Thank you, Abhishek, for your presentation. Now I want to request Dr. Tushar Kanti Bera, sir, kindly please share your presentation. And kindly please, sir, kindly please complete it by 6 minutes.
6.
6 followed by 2 minutes of question. Okay.
Okay. Okay, good afternoon, sir. So we will discuss about mechanical pressure sensing with conducting fabrics for the robotics. So the outlines of the talk is introduction to the impedance, electrical impedance spectroscopy, electrical impedance tomography, then EIS for material characterization, EIS and EIT for the instrumentation, and EIS on the conducting fabrics. And then I will discuss about the fabrics which are used for artificial skin in robotics. And then I will conclude my talk. So we know that impedance is very, very important method. Impedance-based technique can be utilized for the NDT as the NDT for either studying the disease, health tissue, or the food or the materials which are inert materials. But important for our society like photovoltaics materials or any other materials can be studied by the electrical impedance, which is the response of material to the alternating current excitation. So impedance can be measured by using Ohm's law, and we can apply either 2-probe or 4-probe techniques for measuring or extracting the impedance data. So with the impedance data, if we go for the impedance spectroscopy, we can get some models, as we have already discussed in our earlier talks. So the unknown samples or either tissue or any other inert material can be modeled with electrical parameters, which will be useful for characterizing the materials. So these are the 2-probe and 4-probe schematic, and this is the schematic for the instrumentation by which we can generate the impedance data at various frequencies. So this is the impedance analyzer schematic, and we can get the impedance data with the phase angle. Now we will come for the impedance-based imaging. Impedance-based imaging means whenever we will get the data, that data can be utilized for drawing the curves. But if we have some cross-sectional visualization of any body subject or body parts, then it will be very useful for doctors so that we can get some information or more information about the disease or the structure. Even for the mechanical engineer, material engineers, if we have the internal structure or the image, then it will be very useful for characterizing the materials. So the imaging technique was started with the X-ray with the hand of Röntgen, and he was the physicist and he invented the X-ray, and after that the X-ray was used, and it is being used in the field of medical science or also in the material science. But using the computed tomography, we can get the cross-sectional image of the body where the X-ray source is kept rotating, and we will get the detectors data, and that data will be useful for reconstructing the images. In case of tomography, the X-ray source is rotated in 360 degrees and data is collected. So in case of electrical impedance tomography, current is injected and data is measured. But in EIS or electrical impedance spectroscopy, that data collection is done at a particular place. But in case of electrical impedance tomography, we need to conduct that same experimentation repetitively so that we can switch the electrodes and you can get the data for 360 rotation. And that data will be stored in the computer, and computer will give the cross-sectional image of the circle, whatever is the object under test. So if any object has some abnormality, and if the object has the symmetric domain, then automatically the current paths will be different, and that difference will be reconstructed by the mathematical algorithm called electrical impedance tomography reconstruction algorithm, invented by Professor John G. Webster and R.P. Henderson in 1978. After that, those methods have been applied in various fields due to the several advantages like non-invasive technique, radiation-free, that is, X-ray is not used, low cost, portable, and also it is suitable for the bedside measurement or ambulatory measurement. It has been adopted by chemical engineers for visualizing the chemical reactions, and then biotechnology for visualizing the cell culture. Also, civil engineers are also utilizing the technique for identifying the voids and the cracks inside the concrete beams. And the geotechnical engineers are putting the electrodes on the ground, and they are trying to visualize the water and also the minerals stored in the underground. So now those are things have been proven to be applicable for many fields. Now, utilizing the conducting fabrics, we can develop some pressure sensing materials. Mechanical pressure is everywhere in our society, and even in the robotics field also. Whenever robots are moving, whenever they are feeling some pressure, or if they are feeling some obstacles, they need to react. So that type of control system or feedback control system must be there. And if the conducting fabrics are used as a robotic skin, then the robot can sense the pressure like human beings. So this is the concept. We studied the mechanical pressure sensing using the electrical impedance spectroscopy first, then also we conducted for the electrical impedance tomography also. So these are the 4 probe techniques, clipping the conducting fabric material, and we have put some pressures, and we have given some known pressure with the measurement of the weighing machine, and we understood how the impedance is varying. So this is a study conducted in the South Korea University of Yonsei, and after that we collected the impedance variation data. So whenever the impedance data variation is known, we can give the data as a priority data to the impedance tomography techniques, and we can get the impedance images for that. So if we put the pressure on the phantom, that is a say cross section of a circle, and we can put we can cover the domain with the help of conducting fabric, and if we put the pressure, we will get the image of the pressure. So this mechanical pressure is coming as a in terms of electrical impedance variation. So that type of studies is conducted for many research groups, and we also conducted that, and we also got the images. So we will show our experimental setup. So this is the pressure I'm giving with the help of the pen, and we can get the pressure points as a impedance variation in the image. So that type of conductivity testing for the conducting fabric is very useful for robotics, and you can put the skin with the help of conducting fabrics, and if you give the pressure, that entire domain can be imaged with a tomographic technique called electrical impedance tomography, and we can get the pressure point. So if the data is fed to the robot or robotic controller, then automatically robot will realize that on his cheek or on his forehead or on his hand some pressure is there. Accordingly, it can react. So these are some examples. So artificial skin is very, very important for robotics, and robots are interacting with the machines, robots are interacting with the computers, robots are interacting with other robots. So there is the need of artificial skin. Artificial skin is already conceptually proven for the medical field, and we can generate that skin. So that type of things can be done in the material development apart from the biomedical field. So that type of conducting materials can be developed with the help of material science engineers, and we can develop the artificial skins for the robotics. So these are the papers we have followed, and many people are working. And also one future research can be made that conducting fabric can be laid over the bed, and some people who are staying away from the patients, away from the family members, so they can be also visualize whether they will need some medical help or not. So conclusion is that conducting fabric is a very useful instrumentation. So conducting fabric impedance change with the pressure induces deformation. EIT and CT technique is useful for NDT and SHM. EIT is fast, low cost, and portable. EIT can be applied for imaging the mechanical pressure on the conducting fabrics, and conducting fabrics also sensing can be useful for the artificial skin in robotics. And conducting fabrics where artificial skin can be developed for robotics, which will give the sensing property to the robots. Thank you very much. Thank you, sir.
Thank you, Sushakanti sir.
Thank you, sir.
Thank you, Tushar sir. Sir, I am having one question on
Yes,
that.
sir.
Also on doubt.
Yes.
The researchers nowadays already developed electronic skin.
Yes, yes.
So can it is capable to recreate the sense of touch or any other things that will give more valuable or invaluable part to the researcher?
Sir, actually, electronic skins which are there, that type of thing is little bit different from this conducting fabrics. This conducting fabrics is more cheaper. So directly we can conduct the experimentation so that we can visualize the pressure. So cost-wise, this type of skins, conducting fabrics will be in somewhere it will be suitable, where the cost is a big matter.
Okay, so on that cases, robotics can help.
Yes, 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 definitely. Because the robot bodies are in most of the cases the robots are in macro form, means there will be large screen, large say dimension of the screen is required. So if you want to develop the electronic screen for that type of things, it will be a little bit costlier, I guess.
Okay. So thank you, sir, for
Thank you,
your
sir.
nice
Thank you.
presentation and informative session.
Thank you.
And
Thank
now
you.
I request to Dr. Jaitaram, if you are having any query, any doubt.
Thank you, Dr. Tushar, sir.
Thank you, ma'am.
Presentation, I do not have any queries, sir. Okay,
Thank you, ma'am. Thank you.
Thank you, sir. So I request Mr. Atif Hamdan, kindly please share your presentation.
Yes, sir. Sir, is my presentation visible, sir?
Yes,
Hello.
You are sharing. Yeah, okay. It is visible. Kindly please come in the first slide.
Yes, sir. I'm in the first slide. Is it visible, sir?
Yeah, just start your presentation, Atif.
Yes, sir. So good afternoon, respected chair and co-chair and the following and the fellow participants. Today, I'm Atif Hamdan, an undergraduate student of Department of Civil Engineering, ICMMIT University, Jharkhand. And today my topic is on the impact of partial replacement of coarse aggregate with electronic plastic waste on compressive strength of concrete. This is my list of contents. The topic of my paper is rather based on the challenges faced all around the world, particularly in India. Global warming, rise in sea level, carbon plus town and cities are termed used by common Indians nowadays. Among the many challenges faced in 21st century by Indians, my paper covers the three most prominent. That is the population, which is wherein India is fast covering and reaching the population of China, the first largest population of the country. The second largest, India is also the third largest producer of e-waste, second largest producer and consumer of cement, and third largest construction market industry, thereby indicating the generation of construction waste that the India produces. These are some of the data that we have, and we can see that India is in one of the top countries of consuming mobile phones, and the pattern of consumption of cement and carbon emission that are caused in India. Thus, the aim of the paper, the aim of my paper is to integrate this plastic waste efficiently to provide and produce an alternate sustainable construction material which shall protect the environment to reduce CO2 emission caused by the construction and cement based waste material and prevent the threat to environment due to the improper and complex process of degradation that the e-plastic possesses. The replacement of such waste, that is e-plastic material in concrete, will not only curb and prevent further depletion of natural resources of aggregates, but also prevent the adverse effect that the plastics are causing nowadays. The significance of my research work have been carried out efficiently reusing plastic. Now, although there have been several studies which have efficiently used and reused plastic, like PET plastic because of its huge availability, and other studies like HDPE and PVC as a possible replacers in cement and mortar, in cement and mortar and concrete. But however, a very little attention is directed towards the informal sector of WEE plastic. Now, WEE plastic are those plastics which are available in electronic plastics. These e-plastics which are mainly consist of mainly four polymers, that is ABS, PE, PP, and which contributes to 70% of such plastic. Thus, my study takes a significant approach of involving this e-plastic, the ABS and PP, in concrete mix at different ratios, making it a peculiar among several previously conducted research works. This was the plastic that we have used. The e-plastic was shredded and then later converted into pellets. The PP pellet was turned into blue and black for easy identification. Confirmatory tests were also done to identify the presence of such polymers. After conducting the experiment and testing its compressive strength, the following inferences were observed. The figure illustrates the pattern of failure of specimen after 7 and 28 days of curing. The average compressive strength conventional mix came out to be 25.86 Newton per millimeter square and 39.48 Newton per millimeter square for 7th and 28th day respectively. This was an increment in compressive strength of 18.87 after 7 days and 29.86% after 20 years when compared to the conventional mix in the 5% replacement sample. However, a significant downward trend was noted in further replacement percentage of e-plastic waste, that is 10, 15, 20% replacement. The possible reasons for such observation could have been the improper or weak bonding between e-plastic pellets and cement, and the decreased water absorption capacity of cement due to its increase in the plastic content, which is a hydrophobic material. The conclusions of my research work can be concluded in the following points: that keeping in view the experimental observation, it can be concluded that the concrete mixture having both e-plastic content, that is high and low density plastic polymer up to 5% by weight, that 5% weight of coarse aggregate can be used in construction industry with necessary precautions. Further increase in replacement of percentage up to 10% by weight can be used as a cost-effective alternative for non-load bearing structures. But however, the further replacement of more than 10% is not recommended. However, further studies shall be done for its split tensile and flexural strength, and partial replacement of fine aggregates in combination with coarse aggregate or individually with e-plastic waste and its possibilities of increased strength shall also be tested. Other rational possibilities of increasing the size of pellets and addition of different admixture like bitumen or asphalt may also result in increasing the adhesive and frictional property between cement and waste material. In all, with further detailed analysis in future, wherein similar replacement of such waste in concrete shall trace path for a better cost-efficient environment and sustainable, friendly, and energy convenient conserving solutions. Thank you, sir.
Thank you, Atif, for your nice presentation. Now I request to Jaita ma'am, if having any doubt, any query.
Atif, very nice presentation and of course nice effort. I have only one query. Is there any specified place, official space in Ranchi for e-waste only?
Ma'am, there are no specific government entities which manage the e-waste, but there are certain private bodies which collect these type of e-waste. Then they shred it and sell it to big metro cities, wherein they turn these plastic into small pellets, which can be reused in production of plastic chairs and other things. So we also got this got their assistance, come in their contact to turn our e-plastic waste, that is EPS and PP, to convert them into the pellets, which can be used in our concrete.
Okay, and just my suggestion is
Yes,
that you can try out by changing the particle size also.
Yes, yeah, ma'am. We also mentioned that increasing the size of e-plastic may also result in increase of strength.
Yeah, yeah.
Yes, ma'am.
Okay.
Yes,
Okay. Thank you.
yes, ma'am. Thank you, ma'am. Thank you, MIT, for providing me this opportunity. Thank you.
Atif, I am having one question.
Yes, sir.
So you told that you are collecting the pellet. Okay, how it will convert the plastic either waste to the pellet? By using some of the chemicals or by using some of the microorganism, anything?
No, sir. The pellets were converted basically with the outside assistance. So we took the shred.
Convert to the pellet.
Yes, sir. So we took the shredded materials, which we collected the shredded material, tested it for the presence of ABS polymer, and then got a outside assistance from one of the private entities to convert that into e-plastic. They have specified machineries where they can convert such type of plastic into small pellets, beads, or shredded plastic also. Purified shredded plastics.
Okay. Okay. Thank you, Atif, for your nice presentation.
Thank you, sir.
So next presenter is Mr. Gaurav Nandan. I request Mr. Gaurav to kindly please share your screen and start your presentation.
Hello.
Yes, Gaurav.
Yes, sir. Good afternoon, everyone. Myself, Gaurav Nandan, and now I am going to present a short review on cold metal transfer, metal inert gas brazing of dissimilar metal, focused on steel and aluminum alloys. So I will first. Sorry. I will first talk about the welding process. So welding is a joining process of two or more similar or dissimilar metals or materials where a concentrated heat source melt the material in the weld area. The molten metal area then solidify into a to join the piece together. Sometimes a filler material is added to the molten metal to strengthen the weld material. Here we can see from the picture a basic conventional welding process where you can see torch, welding material, weld pool, weld bit, the welded joint between the two materials and the two parts. So now I will talk about the why there is a need for the dissimilar welding. So in material joining in the automobile industry requires rigorous criteria, and the increasing demand of fabricating lightweight structure has generated substantial need to integrate dissimilar metals such as aluminum alloys in stainless. However, completely removing the steel structure with the aluminum alloy is not possible, but we can remove some parts of the steel structure in automobile bodies, vehicle bodies, with the aluminum alloys, for the fulfillment strength requirement and easily available at the low cost. So the best way to produce functionally graded components via joining of the material to achieve all these desired properties. So in last few years, the automobile industries had started to replace conventional welding method with CMT MIG brazing process, which provided less heat input and very much reliable than any other conventional joining process. Previously resistant and nowadays also resistant spot welding is widely used in the assembly line of the automobile sector. So here we will discuss about the inevitable problems encountered during the dissimilar joining of aluminum to a steel and the methods to overcome these difficulties. So we can see in figure 2, one side we can see cold metal transfer brazing, and the other side is other joining process, and the difficulties occur during the other joining process of the dissimilar metal of steel and aluminum. So my objective is to discuss about the problems during the welding of dissimilar metal, aluminum alloy and steel, and discuss about the CMT MIG process, its advantage for using dissimilar materials, and to discuss about the effect of process parameters and the filler wire composition of the weld joint. So why there is a need for joining dissimilar metals? So so currently automobile sector is providing to try lightweight produce lightweight low fuel consumption and environmental friendly vehicle. Other than automobile sector, aerospace and marine industries also fabricating dissimilar metal structure. Replacing with steel with aluminum fabrication of the vehicle body is currently prime area of interest for both researcher and industries, since steel remains the dominant material in the manufacturing of the vehicle. Some parts of the structure can be replaced by the aluminum alloys. So here we can see the different types of welding process for joining of dissimilar materials. One is first one is fusion welding, the second one is solid state welding, low dilution welding and plus mechanical. So fusion welding is most widely used for the joining of dissimilar materials, in which resistant spot welding, shielded metal arc welding, GMAW, GTAW and CMT. So we will discuss about here CMT. CMT is a modified version of the MIG process, which is based on a short circuiting process, based on the short circuiting process. This is a schematic diagram of CMT brazing setup. How it works, the working of the CMT brazing is the motion of the welding wire have been incorporated into the welding process and overall digitally control of the process. Every time the short circuit occurs, the digital process controls the interruption of the power supply, and mechanically retraction means the backward movement of the wire will be digitally controlled. So the wire retraction motion assists droplet detachment during the short circuit, thereby significantly reducing the heat input and smoothly transfer the droplet into the weld pool.
You are having more 2 minutes to wind up.
Okay, sir.
Comes to the conclusion part. Okay.
Okay, sir. So I will discuss about the problems occurs during the welding of zinc coated and mullum part. So first, the problem is the formation nature of IMC intermetallic compound and prediction of the intermetallic layer. So here you can see a steel and aluminum is joined, and there and between them at the interface IMC layer is formed. In this figure also you can see different type of IMC compound which are affecting the joint strength of the welded material. So problems during occur. The several attempts have been made to understand the formation of these brittle intermetallic compounds, as well as to inhibit the formation. The temperature range during the CMT process is most favorable for the thin and aluminum rich intermetallic compound. Due to the near zero solubility of aluminum and iron, invertible IMC layer found throughout the contact surface of the material. This layer may be possibly consist of FeLy brittle phases. It is, and we can see from this aluminum iron phase diagram the formation, how the formation of these intermetallic compounds took place between the interface. Now I will talk about the effect of process parameters, how process parameter affect the joint strength and bead properties of the material joint with the process. So I have compared some took the data from the previous literature and compared that how heat input the heat input generated during the different process parameter affected the strength and the IMC layer of the IMC thickness of the joint between the interface. So in previous research paper it was observed that the IMC layer thickness must be less than the 10 micron for the sound joint. These are the some graph you can see how process parameter affecting the bending strength of a joint. And from here we can see the hardness value, how hardness value is affected through the by the process parameters. Effect of filler wire composition. Now the change in composition of filler wire directly affects the growth and nature of the intermetallic compounds. Hello. The melting point.
Gaurav, kindly please come to the conclusion part. Kindly please come conclusion part.
Okay, sir. So conclusion is a joining of aluminum steel has been common interest for researcher industry for deployed overarching but replacement of steel to reduce weight is limited due to incompatibility between their properties. Formation of hard brittle metal compound, especially FeL3, Fe2L5 at the stable incapable due to almost zero solubility of the solution. Selection of filler wire material, optimization of heat input and other influencing parameters can be used for suppression of these intermetallic compounds. These are the, thank you, sir.
Okay, thank you, Gaurav,
yes,
for
sir.
your presentation. Once request to Dr. Jaita ma'am, if ma'am is having any doubt.
No, sir, thank
If not,
you.
then we can move to Mr. Asif.
Yeah, yes, sir, I have no doubt.
Mr. Asif, kindly please share your presentation and start presentation.
So, good evening, sir. Is it visible?
Yeah, it is visible.
Okay, sir. So my topic is titanium-based materials, synthesis, properties, and applications. So these are the list of contents which I will be presenting. So we all know that today titanium is very important for all of us. So why titanium based materials? Because it is outstanding amalgamation of thermomechanical properties. Transitions metal from group 4 and group 5 such as titanium, zirconium, etc. are used in making titanium alloy with others. It has high tensile strength and excellent wear and corrosion resistance. So these properties make titanium a very useful alloy and for other ceramic based material in industry in aerospace. So basically titanium based material can be classified into three parts: titanium alloys, titanium ceramics, and titanium composites. So these are the types of titanium based materials. So they are come also very handy in orthopedic applications because of their very good properties in biocompatibility, bone bonding, thermomechanical processing, mechanical properties of bones. So almost they match with bones. So it becomes a very good biomaterial also. So the when reviewed in literature, following research gaps were found in the current study of titanium, that the detailed study of process parameter and the effect on titanium materials has not been studied properly, and more energy saving approaches are needed for fabrication of titanium based material. Novel synthesis routes has also to be tried out, and research on novel fabrications should be tried out, which have lesser energy in preparing the titanium based material. So these are the research gaps available in the literature. So basically the first material, the first titanium based material is titanium alloys, and titanium alloys can be further subdivided into alpha alloys, beta alloys, and alpha beta alloys. So you can see the titanium alloys in the picture. It has great application in rolled ring, forged rings, alloy tubes, gas bottles, and particularly in aerospace and launch vehicle upper stage propellant tank in missile technique, and then die forged dome. So these are all types of titanium alloy application. So generally titanium, the crystallographic transformation takes place in the pure metal titanium at 882 degrees Celsius. Below this temperature, pure titanium has a hexagonal closed packed structure known as alpha. And above it, the structure is BCC and term beta. You can see in the figure, and there is some alpha plus beta alloys also there, which may contain between 10 to 15% beta phase at room temperature. So the most commonly studied alloy, that is Ti6Al4V, comes under the alpha beta type of alloy. Now coming to the next titanium based material is titanium ceramic material. So it has high heat conductivity, oxidation stability, and wear resistance. So titanium dioxide acts as a base material in the formation of ceramic based materials such as titanium carbides, chlorides, and nitrides. And the most common route for fabrication is the powder metallurgy technique, which comprises of mixing the different ingredients and compacting them. So, and the fabrication routes for these ceramics are DC magnetron, sputtering method, sol gel, laser process, PVD, CVD, etc. Fabrication routes are there for making titanium-based ceramic materials. And you can see these titanium ceramic metals have a good strength also, which is better in compared to the titanium alloys. Next, coming to the titanium based composite materials. So they have excellent specific strength and stiffness, and they save up to 50% of weight while preserving equal stiffness and strength in jet engine propulsion mechanism. So they come very handy while being used in aerospace and jet propulsion mechanism, because the weight is reduced and they give the same amount of stiffness as compared to the stainless steel or any other aerospace used material. So these are the titanium composites that are generally used: TIC, TIB2, TIN, TIC, TIN, TIB2. So we come to the following conclusion from this study, that particle size of the reactant component and the cooling rate after the synthesis is critical. Sir, I'm audible now?
Yes, you are audible.
Yes, so I'm coming to the conclusion. So we can say that particle size of the reactant component and the cooling rate after the synthesis is critical for titanium-based materials. Then next, solute components significantly affect the transition temperature of alpha LYs, beta LYs, and alpha beta LYs. Next, employed in aeroplanes, naval ships, armor plating, spacecraft, and missiles because of their high tensile strength to density ratio, good corrosion resistant, and ability to sustain reasonably high temperature without creeping. Titanium-based materials are the new materials, innovative materials in all fields of industry. There is no need. There is a need to develop more energy methods to synthesize titanium-based materials. Novel applications are not being researched, and even though titanium-based materials are among the most researched material system, there is a lack of meaningful information regarding to their properties, manufacturing process, and design in the literature. So these are the conclusion from this research work. So thank you, everyone.
So thank you, Asif, for your nice presentation. Now I request Jaita ma'am, if having any doubt.
Don't have any doubt, sir. Thank you, sir.
Okay, thank you, Asif, for your presentation. And kindly please stop the sharing. Now I request to Dr. Giridhar Narule, sir. So kindly please start your presentation by sharing your PPT.
Hello.
Yes, sir, it is visible and audible both.
Okay, sir. So good afternoon, all of you. My topic of a presentation: experimental investigation on compressive and flexural performance of Fortra fiber reinforced concrete. I'm Dr. G. N. Narule from Vidya Pratishthan Engineering College, Baramati. These are my content of presentation: introduction, literature review, materials and methodology, experimental work on performance of the Fortra fiber reinforced concrete, result, conclusion, and references. I would like to focus on the various types of the fibers and the utility in the preparation of the concrete. As you know, fibers are usually used in concrete to control cracking due to plastic shrinkage and to drying shrinkage. It reduces the permeability of concrete and thus reduces the bleeding of water. It improves the concrete by means of enriched flexure and tensile properties. So as per ACF 444, there are basically two types of the fibers: inorganic fiber, that is steel fiber and glass fiber, and organic fiber, synthetic fibers and natural fibers, acrylic, propylene, polyethylene, carbon, nylon, polyester, aramid, and natural fibers such as sugarcane, coconut, sisal, bamboo, wood, jute, etc. So polymeric based fibers are having the excellent engineering property. These are easy to finish, color blended fiber made of 100% virgin material, that is a copolymer, consists of a twisted bundle, non-fibrillating monofilament and fabricated networks, yielding a high performance concrete reinforcement system. It is used to reduce the plastic and harden concrete shrinkage, to improve the impact strength, and to increase fatigue resistance. It also improves the toughness of the concrete, this extra heavy duty fiber offers maximum long-term durability, structural enhancement, and effective secondary or temperature crack control, and incorporating truly unique synergistic fiber system of long length design. Similarly, there are excellent properties, engineering properties of Porta Econate fiber. It is also easy to finish. They fully oriented 100% virgin homo polymer material, and fibrillated network, and that's why there is a, due to this network, there is a formation of the proper bond or good bonding between the concrete and this fiber surface. It is used to reduce the plastic and harden concrete shrinkage, improve impact resistance, increase fatigue resistance, concrete toughness. This medium duty fiber offers good bonding power and long-term durability through secondary or temperature control, and non-corrosive, chemically inert, 100% alkali proof. And on this basis, we have compared the effect of both the fiber by adding into the concrete. So related with this work, I have collected some research papers, and in that I found that most of the researchers, they have done the study separately by using the polymeric fiber or the polypropylene fiber. But here in this study, we are going to compare the effect of the both fiber by changing the percentage of the fiber. So as per literature review, as per most of the research, the Porta fiber can be effectively used to prepare concrete with Porta fiber reinforcement, self-compacting concrete with ultra high performance, polymer fiber reinforced concrete pavement with recycled material, and these fibers are used by many more researchers in a different way for various purpose various purposes. The present experimentation consists of an assessment of efficacy of concrete using Porta fiber reinforcement with the different doses of fiber and compressive strength of the concrete. Experimental outcome expose the comparison of flexural and compressive strength for conventional concrete and Porta fiber reinforced concrete, as well as the possibility to replace the steel reinforcement by means of the Porta fiber reinforcement. Okay, in this experimental work, we have adopted the properties of the fiber, length, color, and specific gravity tensile strength of a different fiber, Porta ferro fiber and Porta Econate fiber. Then methodology, we have adopted the 5 phases for preparation of the samples and testing of the sample. And here you can see the overall test matrix for our experimental work. We have varied the doses for Porta fiber in percentage 0.12% to 0.29%, as well as we have varied the percentage of the Econate, that is Porta Econate fibers, varies from 0.042% to 0.083%, as well as we have compared the effect of this in case of flexural strength. In that we were tested the conventional steel reinforcement beam as well as the pure concrete beam with additive of Porta ferro fiber, as well as separate beam. 3 beams we were tested by adding the some percentage of the that is 1.5 kg per meter cube in a concrete using the Porta Econate fiber. And these are our result. We have stated the concrete cube as well as the beam for compressive strength and flexural strength on UTM and on CTM. Okay, so here you can see the there is an increase in the compressive strength as we will increase the amount of the quantity of the this Porta fiber. Here Econate also, in Porta Econate also, as a percentage of the Porta Econate is increasing, we have observed there is an improvement in the compressive strength. Here also you can see the flexural strength of the beam with steel reinforcement 1%.
Please come to the conclusion part, sir. We have to start the validity, sir, please.
And here for Forta, Forta fiber, without reinforcement, here we are getting the flexural strength 7.47 Newton per mm square, and in case of the Forta Econet 6.67. So it means that with the help of this fiber, we can think for replacing the quantity of the steel reinforcement. So these are the failure pattern in case of cube compressive. At the time of testing the concrete cube, we observed in the failure pattern in a core, that is a cube without this fiber. We observed there were a large cracking, and here in case of the Forta fiber or Forta Econet fiber cube, we have observed the very less cracking. And same thing we observed in case of the flexural test on the beam. So as per our result, we obtained some conclusion. Increase in a Forta fiber, Forta ferro fiber doses in concrete from 3 to 7 kg per meter cube correspondingly improves the compressive strength of the concrete in a range of 10 to 20%. As the doses of the Forta Econet fiber increases from 1 to 2 kg per meter cube in concrete, there is enhancement of the compressive strength of concrete varies in range 7 to 15%. The concrete having Forta fiber at a doses of about 5 kg per meter cube and Econet fiber at a doses of 1.5 kg per meter cube would be beneficial quantity of the fiber for enhancement of the strength of concrete. Addition of a Forta Econet fiber in concrete is more effective compared to the Forta ferro fiber, because this quantity you have seen it is a lesser than the quantity of the Forta ferro as additive in concrete. Cracking behavior of a concrete can be suspended with use of the Forta fiber in a mixture of concrete. Forta fiber alone cannot contribute the flexural strength to concrete beam. Specimens of replacement of Forta fiber with steel reinforcement in some percentage would be convenient to improve the flexural strength, reduce corrosion of reinforcement, since Forta fiber reduce shrinkage cracking in the preliminary phase of setting as well as the hardening of concrete. And these are references. Okay, thank you.
Yeah, thank you, Dr. Giridhar sir, for your last and very beautiful presentation. Now I request to Dr. Jaita Chattopadhyay ma'am, if ma'am is having any doubt or any query.
No, sir. Mr. Girdhar, it was nice presentation. Thank you. Thank you for your presentation.
Thank
and
you.
I don't have any doubt.
Thank you, sir.
Thank you, ma'am. And thank you, Dr. Giridhar sir. So on behalf of ICMMIT 2022, I am sincerely my deep gratitude to all 12 participants, those who present their paper very beautifully and very informatively. And I am also thankful to our session chair, especially Dr. Jaita Chattopadhyay ma'am, conference co-chair and co-convener, for sharing your precious time to be as a session chair. So I request also all the participants, those who are here, kindly please join to the valedictory session. I have already shared the link to the chat option. By registering in that link, kindly please join to the valedictory session. It will start by 4:30.
Okay, sir. Thank you.
Okay, so I request, and I am also thankful to Lalit Bharadwaj ji, especially Arvind ji, for giving the technical support for this session. So thank you all, and we'll meet to the valedictory session.
Thank you, sir. Thank you, sir.
Okay, sir. So shall we close the session?
Above the normal reaction. Yes, Lalit ji.
Okay.